mirrored image underneath in the box. And then in the distance are other boxes that are designating other boats at different distances. So this is the closest boat. This is the next closest boat. I would say this is the next, or I'm sorry. This is the closest boat. This one's the next one that's farthest out. This is the next farthest out, and then this one over here is far. The reason why I'm saying that is because we have less visibility on these targets. So
Give
these
me,
boats are
I
different.
apologize, because I was just, all right, which boat is which again? Just go over that last part that you just went over.
I'm gonna work backwards. This is the farthest boat. This one's next closer than that. This one's closer than that. This one's closer than that. And this is the closest boat that we have here. So we have an inferior Mirage here with this boat. Okay. And we have a limit to the water. So if we start at the bottom of the page or the bottom of the photo and move up, we go at water, 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 what? Here's where the water stops. The Mirage starts here and has different depths to it depending on the targets that are in the Mirage. Okay.
Okay, if I may just back up a little bit. When you say inferior Mirage, can you just describe that briefly?
An inferior Mirage is an inverted image of a target that is a reflection of that target.
Okay,
so you have a physical boat, and that physical boat is the image of this physical boat is inverted on itself below the physical.
right, almost looks like it's sitting on a mirror or something, huh?
All right, let me see if I can find something that's going to give you. So in this image, we have an oil platform. Okay. So you've got this boom here, this boom here. This is probably a control deck. You've got a boom right here. This boom comes down. This is the physical boom here. Physical. At this point here, the refraction kicks in and the inversion of this image comes back out here. So it looks like a duck bill, right? You get that?
I see that.
Okay. So everything between these two yellow lines is a mirage of this image here. It's an inverted image.
That's wild.
Okay. Let me see if I can find the problem with inferior mirages is that the clarity of the image is going to be distorted because the refraction that's in the air. So it's always going to be a little less than pristine in terms of if you want a crisp, clear image. Let me see where I can go from here. Let me show you. Here's one of my. This video here is from July 8, 2018. This was one of the first images that I took on the Chesapeake Bay. I just set up my camera, just started shooting to find out whatever I could find out. Okay, so I'm just going to zoom along here. Now,
what time of year is this? Look like
July.
Summer? July? Okay. Everybody's out having some fun?
Oh yeah, man, it was active. Crazy people out, kayakers, sailboats. Okay, so what I'm going to do, I stopped it right here. This is about what I would say we could see with our eye. Okay, now looking out here at our eye level, this is the shoreline, and we can see the inferior mirage already, or I can. Okay, I can tell that we've got a doubled image here. We've got a doubled image over here. But this is what you can, what I'm trying to show you right now is like, this is what you could see with your naked eye. So if you only could see these lighted portions of the distant shoreline, you wouldn't necessarily be able to tell that they were inverted on themselves. So I zoom in. So right there, I'm showing that the tower is like in a dynamic. You see how it's dancing?
Right. It's almost like looking through water.
Right. Now, I don't remember the day itself, but I wouldn't say that it's like crazy hot, like, oh, that's a heat. That's I tend to think that those effects are probably something that's not dependent on temperature, barometric pressure, things like that. Okay, so
Travis,
here,
Travis,
yeah,
can you just do me a favour there? Can you just run us backwards and forwards through that observation with the water tower there, please, mate? My screen wasn't showing; it just went blank. So if you can just run me through it again.
Are you back up with a visual?
I am indeed.
Okay, so here's the water tower, and I'm just going to zoom into it. And basically, I was just pointing out how it was dancing through.
Okay, so looking at the optical displacement of that, obviously physical water tower, due to what would you say that is, Travis?
Well, I wouldn't have said yet displacement. I'm just showing that it's moving. And if I could, let's see, like if I would have held it, I'm just trying to see if I hold it. I don't. I guess, yeah. Let me go back. So if I were to just hold this still, we would see the air apparently making this water tower shimmy. But then we would also see that effect is also going down into the trees as well. Like it goes all the way down to the water line. So like everything in the air right now is, it's almost like what Hammer said, looking through water.
Yeah.
Right. So that was my only point with that. I'm just kind of.
All right. Thank you for
You can,
indulging
yeah.
me there.
It's also
Sure.
interesting how, like you're saying, it's most likely going on everywhere with the trees, but it's more apparent with the lighter object, right? With the tower being
Sure.
light, and on the shoreline, like you can see it clearer when you were pointing out like the lighter parts of the shoreline. You could see that doubling image a lot better, like right there, up especially, right, with the two mouths, the two those look. The one on the right looks like a
Snapping
turtle
turtle.
mouth, bro.
Yeah, I
Turtle.
just
Go
Yeah,
Turtle
yeah.
Productions, baby! Shout out.
Yeah.
Yeah, I just noticed that too. So yeah, so if we look here, here's the physical coming down right into this area here is where the Mirage is going to kick in, so that you have the inversion of that curve down here. This eyeball is right here, and this dinosaur fan back starts right here, but we don't have enough of an angle. So my prediction would be, if I could elevate myself, we would possibly see. No, I'm thinking that backwards. If I lowered my view, I would possibly increase the refraction so that this would actually grow, and I would have a full inverted image. Okay, so this boat right here has the entire image inverted. This one does not. We cannot see the top of this image here. We can see the bottom of it start right here, but it stops. The limit of the Mirage is right here. Have the same thing over here with this, whereas we don't have any of this here at the top mirrored here. It's just this part right here that's a C, and then right here, boop. So that only goes about as far as right here. But the boat, when we come in, okay, I'm just going to stop it right here. Like, what is this? like, I don't even know what to, like, what? It doesn't look like anything, right? You can't see the hull. All you can see is this person standing up, the Evinrude motor here. So you have to cut this image in half. You cut this image in half. The physical is above, the Mirage is below. The internal reflection that's happening in the Mirage is blocking the entire boat. It's right here. Okay, so let me go back to the image that we had before. Okay. This boat is right here. We can see the hull. If this boat were right here in the same position as this one, we wouldn't see any of this. It would be swallowed up like it is right here. But the boat that these guys are standing on, where is it? It's right here. But you can only see them because they're high enough above the angle that swallows up the rest of the target. So I'm trying to show you here, we've got a boat that's closer to us. We can see the hull. So that now, if this boat were closer to us right here, we'd see everything. And there wouldn't be a Mirage if it were right here. And if I could then tell those guys, okay, guys, go into the distance. Okay, stop. You're right before the Mirage, guys. We'd see the boat. And then, as they go here, they would continue to travel up into perspective, and the boat would gradually get swallowed up. And if these guys kept going into the distance, they would eventually disappear and be swallowed up by the refraction. Okay. This was one of my first. It took me a while to learn how not to zoom in too far because you lose. Oh, there's another boat right there that was closer to us. So you can see the boat there, right? And if I were to zoom in, it would be pretty close to right where the Mirage would start. But it took me a while to control myself. So right here, I keep. It took me a while to control myself to only take it to optical zoom. Because then once you go to digital zoom, you're just magnifying the final focal length, and it's not great imagery. But here you can clearly see almost an ice cream sandwich of a boat, right?
Yep, I see that. And when you so you can control optical and physical or optical and digital zoom on your camera.
Right. Like if I zoom in right now, here we go. That right there, right where it stopped, did you see that little jolt?
Yeah.
I'm going to back it up. Watch for the camera to automatically stop itself. Right here. That's full optical. So you see how distorted this image is? So if I go into digital, it's just going to magnify this distorted image. It's not going to be any clearer. So to me, it's not worth zooming in at that point. So now I'm going to probably pan over. Let's see here, there. I'm just showing you. I just did that. I just went into digital zoom. Okay, so this house right here, here's the physical roof. So, okay, in this instance, we have the full target, right? We've got the roof right here. Remember how we saw the turtle and we didn't see the back of the turtle? Like this is the back of the turtle. But here, because of the elevation of the boat and the distance in the Mirage, we actually get the roof. Here's the roof right here. Although it's distorted because it's not a symmetrical mirror, right? We've got more of a rectangle here, and then here it's reflected, but it's distorted more. But my point is that the entire target is here. So I don't know.
So what do you what do you draw from that? Like what?
Okay.
What's the significance as far as
So the significance is, here we go. Ready? The significance is this boat is horizontal to this boat. This boat is horizontal to the shoreline that's out here that we can't see. It's in a mirage. Okay, but so we're just looking over the horizontal all the way out. Okay, so if we understand that, let me try to find maybe a better shot somewhere. So this boat is fully visible, no mirage. It's on the water, and we can see it, so that when we get to a point where there's try to find another boat. I think that's a boat out there. Hold on. So this sailboat right here, all we see is a smudge of white. This is a boat that's, you have to cut the image in half and understand that the boat is right here. You just can't see it. So we're just looking over the horizontal the entire time. So basically, even though we can't see the shoreline is right here. 9 miles away, the shoreline is right here. So the implications of this, again, are that there's no curvature, because 9 miles away, there should be at least 50 feet of curvature, which would then mean that the shoreline can't be right here. But if this boat is closer to this shoreline and they can see it directly and I can see it directly, then this is just a straight line of sight all the way across, no matter what the distance. So the implication is, let me go back to the boat that's in a mirage. The implication is that this boat is physically in front of me. And when it's in a mirage like this, even though I can't see the hull is still right there. This boat is a little bit farther away than this boat, and it gets swallowed up. But the hull is still right there. And then we go back to the one that we saw before with these guys. The physical target of the boat is physically right there. So that when you have the mirage, simply because you can't see the body of the boat doesn't mean it's not there. What this image has done in the past is mariners out on the ocean see the water stop. Boom. Here, I'm going to have to go to a different photo so I can show you. If you have any questions, go ahead and ask, or talk amongst yourselves. I'm looking for one, a particular boat, image of a boat.
Any questions from the audience?
Well, to me, it looks like, hopefully I'm coming through okay.
Yeah.
In those images we were just looking at, you can see the mountainside or the, land right there being reflected down right there on the water. That's really just that horizontal aspect is clear, and it's just that reflection that you're seeing.
Okay.
Definitely not Earth.
Okay. Okay. This freighter right here. Okay. This freighter right here has the mirrored sky underneath it. Okay. You can see the yellow orange line, right?
Oh
Yes?
yeah, I see that.
Okay.
You called it what exactly?
I don't know. I just called that. I was just describing the color. It's a yellow mirrored line.
Okay. Yep, I see that.
Okay. Okay. So we can't see the hull. Like here's this boat. We can see the hull. Now, and we can see the hull of this boat. Now, in this one, we can see a bit of the hull, but we can't see where the hull here is meeting the water. We cannot see the boat on the water like it is here. This boat on the water, this boat on the water, this boat can't see the water, but guess what? It's on the water. You just can't see it the same way here because of the inferior mirage. Now, increase this distance here. So here's my point. This boat is right here in front of you. You just can't see the hull. This boat right here is smaller, farther away, and you can't see the hull. This freighter out here, you cannot see the hull. But we have documented interpretations of images like this that are called superior mirages. That is, these observers see the water, they see the water, they see the water, Earth curve. This boat has to be lifted up because look at the sky beneath it. Well, I can see the sky. There's the sky. This must be floating. This must be the Flying Dutchman. How is this boat floating in the sky? Well, it's not. You have to understand it's so far away, it's behind the curve and it's being refracted up. That is one of the scientific interpretations of a superior mirage. Okay?
To lift it up.
But yes, it's lifted up.
Aspect. Okay.
Okay.
So we really seeing the boat there in that picture?
You're seeing the top of it, just like you're seeing the top of this boat. Here's the top of this boat. Here's the inferior mirage. You can't see the middle part because of internal reflection. So in this boat right here, the whole boat is right here. The entire boat. This part that's down here is not physical. It's a mirage. Okay, so now I'm going to come over here to the ship that's on the Chesapeake Bay here. Same thing. This entire black line here is not physical, but it's interpreted to be physical. You have to understand that here's the physical, here's the mirage. Okay, so this part up here that's the tree lines in the distance is right here in a mirage. So if you look at this upside down where the fingers of my cursor are, you see my cursor?
Yes.
Okay. My cursor is moving along the inverted image of what's right here. Here's the top of the barge. This is the top of the barge. Where's the rest of the barge? Right here in this refraction.
No takes. I kind of cut you off. Did you have something you wanted to add?
I was kind of looking for maybe a little clarification. If so is the claim that on a couple of things, right? Is the claim that the mirage is always below the physical image, and is it is it a claim that it is reflecting off of air or reflecting off the actual water?
The claim is that the image is always below the target and it is always in the air. The image, an inferior mirage does not happen on the surface of the water. It happens in the air above the water.
Thank you.
This is another, well, I don't know if that's clear. So let me see if I can pull up a still. Is there a still where I have that? Sorry, guys. This is like
Take your time, man. Take your time.
Yeah.
I was just gonna say, did
That's
that clear it up for you? No tanks? Because I was kind of trying to formulate that question that you had, and I liked how you answered it.
Yeah, I mean that
Or how
did
you
clear
asked
it up. And then I mean, are there any situations where then you'd have to? I feel like you'd have to check. Are there any situations where the mirage is above a physical object, and then how do you approach that kind of situation if it even happens? I don't know if it happens.
Yeah. So I've done this on my channel where I've, in my opinion, I'm the only one saying this, and it doesn't mean that it's right at all. The way superior mirages have been described to us is incorrect. There are no superior mirages. Every mirage is an inferior mirage. Now, that is not to say that there's not crazy refractive shit that happens above targets. I'm not saying that. I'm saying that the basic approach to explaining superior mirages is incorrect, and those explanations don't exist in reality. They are wrong. Every mirage is only an inferior mirage. So what we're going to see right now is the same target, okay? And I'm going to ask you to consider this target here a boat, okay? Let's pretend that this is a boat. We have the water, the water, the water, the water disappears, and we apparently see sky, right?
Everybody seeing that? I see it.
Now, when this happens out on the ocean, and you apparently see sky and then a target above it, what is this? It's a ship. We know that this is a ship, but we can see the sky underneath it. It's never been interpreted to be an inferior mirage. But I'm showing you right now, this is land 12 miles away. This is land. There's no fucking way, there's no way that this is the sky, because land doesn't float above the sky. So we have here an inferior mirage. Everything above here, physical, 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 physical. These two trees are my marker as I shoot these targets. If we were to make this a grid of 9 squares, I place these two trees typically in the middle square in the left upper part of that orientation. So what I'm trying to say is that this photograph over here, this second pane, is this image here oriented the same way. I try to take these pictures the best way I can, oriented the same way every single time. Okay, so we have here the same target. Here's the two trees, here's the two trees. Okay, so physical, 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 all right. Now right here you can even see that it blurs. Okay, so you have to cut this image in half. This is where the inferior mirage starts. So where my cursor is right here is the shoreline. This is the shoreline. If you were standing there waving at me, I wouldn't see you, because the reflection is swallowing you up. So
You'd have to be up in the trees there for you to be able to see.
Yeah. Yep. Or closer. Or if you were in a boat closer, you could very well be right here. I wouldn't see your boat, but you could wave at me, and I'd see you, and then if you duck down into the boat, you disappear. But my point is that if this were a ship out in the ocean, let me see if I can do it like this. I'm going to try to make this so big that, all right? If I'm seeing the water stop, the sky, the ship, the interpretation is this ship is actually behind the curve, so I can't see it, and the refraction is bringing it up. my claim is when people and when science tell us that this is a superior mirage because it's bringing this ship up from over the curve, they are looking at an inferior mirage and they don't know what they're looking at because they think that is the actual sky. They think that this is where the water ends in this appearance is because of Earth curve. Okay. And when you go to
Could
the
you, Matt, what is the
websites,
distance that you estimate at that point? Like, what is that distance? It's not very far.
the one that I was just showing you,
Yeah.
that I've done a couple of live streams where I've gone through on Google Earth to the points that I shoot. This tree line right here is 12 miles away. Okay. So if we were to, again, we're simply looking over distance.
Right.
At this point right here,
What is that
because
distance? That's what I want to know.
right, exactly. Well, I'm standing on the shoreline. I'm 5'10". This is roughly 3 miles away. This tree line here is
3 miles.
Yeah. This tree line here is 6 miles. This tree line here is 10 miles. This tree line here is 12. So just as right now is my cursor, I'm not looking up. We are looking over distance. So from my feet to right here is 3 miles. That means from right here to right here is 3 miles. That means from right here to right here is 7 miles. And that means from right here to the shoreline over here is 9 miles. So within this mirage, we have different distances that are affected by the mirage. Like I said, if there were a boat right here, we would see that boat in relationship to its distance and place in the mirage. If we had a boat right here, no mirage, we would see everything the boat has to offer us. If the boat goes slightly into the mirage, we will start to see the effects of it, where we might see the entire boat and then the mirror beneath it. And then as it goes farther and farther away, we lose the differentiation between the top and the bottom. And so basically, here's another idea, is that whatever this degree is, however you want to measure this degree from where I'm going to cut this image in half to right here, that's 9 miles of distance. And so if you think about foreshortening and perspective, right, you know that as you go farther and farther away, the distance gets smashed into a smaller and smaller angle. So that you see the difference in the color here, how it's light blue, light blue, light blue, light blue, right? You see that?
Yep.
Okay, so now from this point right here where it starts to transition into a darker blue, how far is that distance? Let's put it at, let's say 100 feet, right? Well, if we go another 100 feet, it's going to be a smaller angle, but still 100 feet. And then if we go farther 100 feet, it's going to be a smaller angle, but still 100 feet. But now we've gone 400 feet, and the entire way that we're going, it's getting compressed visually due to perspective. So we're not losing any distance here. This is all 12 miles away. We're just looking straight across to the shoreline right here. And I have other images where I can show where, let me see if I can actually find that.
Well,
again, if anybody
on that image though, so what? Because I'm kind of curious. Like, I know we're calling it a mirage, and like, it's the conditions of the air, right? Because you have two opposing images there, and they're a little bit different depending on the day, right? Is that a comparison of that? And
right.
So maybe we're gonna get to that. Maybe I'm jumping the gun here a little bit, but like,
no, it's okay.
causing
Listen,
this? You know what I mean? What would be causing?
Yeah, it's
disruption in the image there.
Basically the basic variables in Mirage are temperature, air pressure, humidity.
And that's it.
Yeah, that's basically it.
No geometric anything involved there, huh?
Right. So here we've got the two trees, and before, in the image that we were looking at before, here we can't see the. Where'd it go now? I lost it. So you see this field?
Yep.
We can't see that field here, but it's right here. It's right there. Okay. So here's
that's
this.
the same area you're taking, same picture. You zoomed in.
Yeah. No, see, look here. The focal length is exactly the same. And this is the problem that the ballers have. They will see that the position of these two targets is not the same, and they're going to go, Travis, you're not in the right place, man. You've got your camera and you've got blah blah. You know, they'll come up. No, I set up in the exact same way every single time. The reason why this water line is higher than this water line is the refractive index in the air on that day. But you can see here that the inferior mirage here is much more acute. Here it's obtuse. You can see more of blurry. You know, this. If you did a pixel count from the top to the bottom, this is bigger than this. You can even see how it comes down, and then it's a tighter hourglass right here.
Oh yeah.
That hourglass is not right here. So the intensity of the mirage here is due to the conditions through which you're looking.
And do you know the conditions of the 2 days? Like, was it higher humidity one day, lower pressure, lower temperature?
Yeah. Early on, I didn't look at any of that, and there were days when I did do that. For me, I don't think it's enough for me to just look at where I'm at. I would have to know what's happening along this entire corridor if it's uniform the entire way. But I haven't done the scientific analysis of the conditions in relationship to taking these shots. Like, that's why I would say I would need a team of people, because I really don't give a shit about numbers and about the measurements. Like, I don't geek out on that. I would rather be taking the pictures and having Billy Joe Bob be the one that's marking down all the temperatures and stuff like that, so that when we then pull this image up on the left, and he can look at the time of 7:47 in the morning on August 10th, and he took down and was like, okay, look, the air temperature is this, the water temperature is this, blah blah blah, and he could do that. But for me, it's hard enough for me to keep, as you've seen already, keep track of the pictures that I take. So it's a team effort on this. Whether or not
Really
somebody
is.
wants to consider, if someone wants to consider that a cop out on my part, then whatever.
You're only human, man. I think
so
we try to be one-man armies too much, bro. It's a good point that you're putting out there. It's definitely a team effort, and sometimes, like, I think it's a facade that they put out there, right, as like one person doing all this stuff, when it really is like a team of people behind them. And then people kind of get defeated in there. They're like, man, there's no way I could do all that, right? But it really is a team of people most of the time doing it. So no, I don't take what you just said as a cop out at all. Are you trying to get in, DP? I apologize.
Yeah, I was just briefly. I've successfully cleared up the disaster in the kitchen, so I thought I'd hop back in. I've been listening, but unfortunately I haven't been able to watch. Travis, great job so far. I feel
like I'm choking so much on my words, but I appreciate that. Go ahead, DP.
Can you just explain in a little bit more depth this like compression zone? Because this is how I kind of view it. Is there's like a zone of confusion that is X amount of degrees above and X amount of degrees below the horizon line that we look at that nice, crisp, clear horizon line you see at the beach on a nice sunny day, there is always a degree of I'm going to call it optical confusion, and depending on the conditions of the day, this zone seems to stretch in the vertical plane to cover more of the horizon above and below the horizon line. And like I say, I kind of choose to call this the zone of confusion because it's where everything gets confused. Now, I've been out and done a couple of tests last couple of years with a few different people, and what seems to happen is your feet come up into that zone at I say a lot slower rate, but a significantly slower rate than your head is compressed into it. So the bottom plane, if you like, seems to compress optically into that zone of confusion at a slower rate than the reality plane, if you like. And I'm just wondering if this is something that you've come across.
You know what? I mean, I think I can understand a bit of what you're saying, but if you had something to walk us through and show us, I think that would be a better way to address your question. At this point, I don't know that I could answer other than to say, yes, at the point at which you're referring to the focal point or wherever your eye centers, if that's what you're trying to allude to.
I'm trying to get hold of some of the pictures that reference what I'm talking about and the way that I'm talking about it. And the thing is that the pictures that Bev's got hold of, or they're pictures that were taken in that server, and they've become a kind of a bone of contention between FE Dogma and Bev, i.e. FE Dogma is using the Blackpool Tower in the background to obfuscate from the point that I was trying to make in the pictures, and that point being that as Bev walks away with the measuring pole, that the rate of compression of the ground into that vanishing zone, I'm going to call it, that zone of confusion, happens at a lot slower rate than the compression of whatever is above that horizontal plane, if you see what I mean.
I was actually, I do. And I was looking for something that we went over yesterday in yesterday's stream, but Beerman didn't put it in here. And I thought for some reason he sent it to me, but I don't see it right now. But he had a video. You know what? I can probably just find it on me. Whatever. Yes, I do understand what you're saying. And it's almost like there are innumerable panes of glass along that distance. And as you walk through each of those, they each have their own interaction with the target.
Yeah.
So that almost like if you watch someone walk away, they seem to be walking away at a faster rate, and you could see that they are moving over distance. But at a certain point, they actually look like they're slowing down, and they're not moving forward at all. It's almost like they're forward moonwalking.
I've not looked at it that deeply, but yeah, I can understand the point that you're making, and that kind of backs me up that the bottom half of their image, if you like, isn't moving as quickly as the top half.
Yes, I get what you're saying, and yes, I would say I would affirm everything that you're saying exactly.
Right.
So
well, like I say, I'm trying to track this video down. It'd be handy if Bev could send me a copy of the video. I might look through his YouTube channel to see if I can pick it up. But like I say, I've been in touch with FE Dogma, and I can't get in touch with Bev, unfortunately, to ask him directly. But I'm sure you're aware of the video that I'm talking about. It's the one with the Blackpool Tower in the distance.
I am.
Yeah. That if you go through that video, the point that they have taken it to, i.e. the Blackpool Tower in the background, is a mute point. Watch the focus and the meaning that I meant behind the video. Concentrate on what Bev's doing and the way Bev walks away and the way he disappears into, or not him, but the measurements on the pole. is the thing we were focusing on, and it strikes me that you've done this at a long distance, and kind of not knowing about it, I've done it at a closer distance. We're looking at the same thing, the same effect.
Okay. So, picking up where I heard DP mention compression, so I pulled this up. There. So, in this image here, you see this image?
Yep.
This
Yep,
is
I'm with you.
probably one of the best pristine in terms of angles and color. We can clearly see the stairs. We can clearly see the banister. We can clearly see the bottom floor. We can clearly see the roof.
Yeah.
Over here to the right. Go ahead. Were you going to say something?
I'm just saying that is Chris. Well, and what distance are we looking at here?
That's I'm going to round up to 6 miles.
Nice clear shot at that distance.
Okay. Right here is the boat dock, and you can see it. You can see the pylons. And you can see the planks. That would be the middle where you would stand. That's the boat dock.
Okay.
This is the shoreline. So I've got a line of sight to the shoreline 6 miles away.
Nice.
Now, all we have to do is stop right there, because 6 miles away, the shoreline should be at least 14, 15 feet gone.
Mm-hmm.
Okay. Now, if you're going to claim looming, then you're going to have to prove the temperature, prove the conditions of the day, and show me other images that you have that you think are looming. Because in my opinion, looming has a completely different presentation than this. It doesn't look the same. It's always going to look like looming is always going to look like looming looks, just like an inferior mirage is always going to look like an inferior mirage looks. So we can clearly see the red roof of this pavilion right here. We can clearly see the posts. This pavilion is about 20 feet tall, and it's about 30 feet off the shore. Okay, so there's a little bit of an increase in elevation, and we can maybe say this should be like 30 feet elevation. Okay.
Yep.
So now I'm going over to there. I changed the levels on that. Now,
Can you just explain why you did that? Why did you change the levels?
I suppose just to see I think just to see if it cleared up anything.
To take any of the scratch and the noise out of the picture.
Yeah.
And because basically by doing that, would you say it gives you a kind of a different scope of view over the picture, just to see what is more visible, what becomes more visible, and
I would say no. I would say I would be perfectly happy with this, but it's not a natural color. You know what I mean? Like, so many times, yeah.
Would you say it'd be fair to play with the levels and the hue and the saturation in a picture where there could possibly be glare, for instance?
I don't have a problem with doing anything that you want to try to clear up your image for whatever reason. So, like, for instance, this is a highly refracted image because it's distorted, right? You can't see with clarity what you're looking at that you can see right here, right?
Mm-hmm.
This is the same house, same focal length, same distance, but the distortion due to refraction here is greater than here. So it doesn't matter if you mess with the levels, saturation, this isn't going to clear up. You're not going to undo this.
All right.
So to me, that's what I mean. Like, you can do whatever you want. If you want to make the water more blue, if you want to try to bring out the colors of the trees or whatever, do whatever you want. Mess with the levels. That's not going to change the target per se itself. Okay.
Right. Okay.
But okay, yeah. So again, if you want to interrupt me at all, go. Feel free. So again, here's the same photo that I just showed you. Here's the boat dock. Here is the pavilion. Over here, here's the pavilion, but I can't make out the boat dock. Right? I can see, look, I can see the Smurfing rocks. I can see the contours of the rocks. I cannot. So you've got compression plus the refraction is just going to distort it all to shit. But my point is that the shoreline is still right there. The shoreline is directly in front of me. Now, what I appreciate about this target is that this antenna is always right here. I always orient this antenna in the top left corner. And all of these images here are the same focal length. And in the post-production, I tried to line up the antenna, the tower straight across, okay?
Yep. Looks
Now,
like you've done a good job with that.
Okay. Now, if I tried to line up the house, the antenna would not be lined up. The tree line would not be lined up. So it doesn't matter which target I find here and try to say, okay, look, here's the pavilion, here's the pavilion. I'm going to overlay those on top of each other. Everything else is going to be off. Nothing is going to match. So the only reason for that, and so if I showed Zanuck this picture and this picture, he's going to tell me something like you're not using the same focal length and you're not set up in the same position. But I am, and I did. The only variable that I can't control is what I call the aether band, the conditions of the medium. So this yellow line right here designates the limit to the water right here. In this image here, here's the house. Here's the house. I can't see the shoreline. So you can see right here the red. That's the roof right here. It's inverted. Here's the reflection down here. So then if I were to overlay this, you would actually see, well, there's the shoreline. So there's the shoreline right there, but you can't see it. Now, here's the red roof pavilion right here, right? Here's the house. Let's go over and find the red roof. Where'd it go? Where's the red roof? Where'd it go? Where's the red roof pavilion, guys? It's right here. It's right there. I could be standing in front of it waving at you, and you wouldn't see me. But I could stand here and wave at you, and you'd see me. Now, the position of the house as well is going to be off from the position of this house. So anyway, the yellow line right here designates the limit of the water in this image. So in this image, I'm looking over water, water stops. Here, I'm looking over the same water, doesn't stop, there's the shoreline. So, where this yellow line starts is where this mirage ends. So if I could put a boat right here, I would know how far that boat is from the shoreline. Now, due to foreshortening, how far away is this distance? Right? I'm saying that could be 2 miles. This mirage, therefore, is stretching over 2 miles of distance, which goes into my claim that the image of the mirage is not vertical, which is what science says. Science says that the image of the mirage is a vertically displaced image, and vertical is 90 degrees. It has a zenith. It's perpendicular, right? Vertical. But this image here is not. It is along the distance from here to here. It covers.
I would absolutely agree with you there, Travis.
I have a
That
question
is,
on that, though.
it's like a reflection across the water surface.
Exactly.
Wouldn't it seem
Yeah, go
there,
ahead.
though, that because the water is kind of, it makes it look like the water is obscuring more of the background there, right? Would you agree with that?
I don't know what that means. Say that. What do you mean? The water. Which imagery you want to talk about?
On the right?
Okay. All right. So the water that we can see is only right here.
Right.
We can't see any more water than that. So then walk me through what you're thinking.
But okay, so compared to the one on the left, like, are we looking? So when you're talking about foreshortening, right? Because this is something that's happening through the medium, right? And we're talking about foreshortening here. And I mean, technically, it would start like right at. I mean, we're in the medium as well, right? So it would start like right where you're at. No,
Sure.
you follow me there. So
Mhm.
is it in? Because you made a kind of a comparison, like with the yellow line, and like those are the same distances. But why wouldn't where this water per se, where you actually see the physical water end? Why wouldn't that end up being a shorter distance because we have more
Yeah.
of this?
Exactly.
Okay, so I am
No,
tracking
that's
there. Okay.
Yep. That's a fantastic question. And the thing that we need to realize is that. Let me see if I can do this. I have other images that are better, but so look, the water here is blue. The water here is brackish brown, right? Whatever is going on in the Susquehanna River here, it's what it is. But the texture, not the color, the texture of this water is different than this. And as we see, the way I describe it is this water looks like I'm closer to it and lower down. And so there's magnification happening here as well.
Right.
So there's less magnification here because we can see farther, but the appearance here, and I have other images that I can pull up that'll demonstrate this as well. But that's to the point that you just brought up. Go ahead, DP.
That's the point that I was going to ask, or a question I was going to ask. Does it appear to everybody that the house on the right, in the picture on the right, appears magnified when compared to the house in the
Yeah.
image on the left? And is that magnification equal in all directions?
Right.
I'd say yes, it is. And even if you look, I'm glad you brought the image back up again, Travis. If you look to the image on the left and the far extreme of the image on the left, the road curves up slightly. And you can see this, you can just make it out in the image on the left, I would say. If you look to the image on the right, that curve in the road is much more pronounced, emphasized. It's a lot clearer to see. And I was going to ask you if you felt this was barrel distortion in the lens, or if it is something that is due to the because I would say it's a magnification effect, that it's made that feature more pronounced.
It very well could be. That very well could be. I wouldn't know how to begin to address that in terms of barrel distortion, because the same barrel, is right here.
Absolutely. So
Same focal length.
yeah, and if you
Yeah.
go through the pictures to the left of that, then there would be none of that. No, see, look, it doesn't look like it's been barrel distorted.
Sorry to interrupt there. I think you made mention of the tower in these photos, because is that the tower that you were talking about is always there to the left?
Yeah.
I just noticed.
Well, no,
that,
I mean, you know, it's I'm thankful for it because if I were to orient my photos on this house, there would be times when the tower wouldn't be in the photograph, because I have other images where there's less, where it looks like I'm zoomed in closer because the field of view is shorter. So I always keep the antenna right here, so that it's my marker for how much the rest of the image has in it. Let's see if I can. Okay. Uh, let me think through. Where's my? I'm trying to think of my boats in the band. Where did I put that file? Boats in the band. Trying to see if there's anything while that's loading. This is a good one. I think will show the same idea that I was talking about before with the magnification. And this goes into another claim that I have for the science of Mirage. This is okay. Can you see this?
Mm-hmm.
We are up.
So, okay, so in this target, I use the channel marker as my orientation. I try to always have it in the right, somewhere in the middle, right? Remember I said I've got a 9 square grid, 1, 2, 3, 4, 5, 6. So I typically try to put this somewhere in 6, even though it might overlap 9 and 3, if that makes any sense. This is basically, okay, this is oriented on the right side.
So
Oriented,
the center of the buoy is center of frame.
give or take, because it's moving.
Yeah.
It's tethered. So I'm not trying to make precise claims based on the position of this per se. And so in this image here, you can see that I've marked out that I'm at a 268 millimeter zoom. And this one's 357. That's the full zoom in the P900. 357 full zoom. Okay. Now in the 357 here and the 357 here, let me go back over here. This this cape is roughly about 6 to 7 miles away. So between this cape and this landscape here, the Chesapeake Bay goes up into Delaware. So if you can picture that between there, you're going up, up the river. Okay.
Yeah.
So I also try to take photographs where I get both the cape and the channel marker in the frame as well. In these two, with the full zoom, I could not fit the cape to the left in either of them. But my point in this is right here, where I've marked this niche in the tree line. This niche in the tree line is this niche in the tree line is this niche in the tree line.
Okay.
Now, in my opinion, I can clearly describe this as magnification, because this tree line is much larger and closer apparently to me. It looks like it's closer. It looks like it's larger. Would that be a fair
I agree.
description?
Yeah.
So,
would you say that magnification is equal in all directions, or applies evenly across the object being magnified?
that would be where I would hire a third party to figure that shit out. If you want, if Billy Joe Bob's cousin, Billy Jane Bob, wants to do that part, let them figure that out.
Y equal
Like
DP.
I just, my eyes glaze over when I try to like figure that shit out.
Well, I'm just curious about the question. Like, why equal? What do you mean by that?
Well, to me, magnification occurs equally of objects when you're looking through this kind of medium. I mean, there are people who say that the magnification only happens in the vertical plane, and there is no mechanism for distortion in the horizontal plane, i.e., there is none of the temperature differential wouldn't happen in the horizontal plane, but you do get cooler air corridors, and the convection of air would lead cooler air being convexed around warmer air. So you would get like temperature fronts at a smaller scale when you're looking across at observations like this. So why would that distortion not happen in the horizontal plane? I kind of feel that the magnification is equal when you look at these things. I mean, looking at that house in the previous picture, I felt
Well, it's like
deep down.
selective. Oh, sorry.
Yeah, go on.
No, I cut you off there. Finish your thought.
No, it's just that I felt deep down that that house had been magnified equally in all aspects. And I looking at that house, I was seriously questioning myself. Does it look magnified equally all the way around? And to me, yes, it did.
Well, it just goes back to like the selective nature of their argument in that, these things only happen in these circumstances, or it only happens in the vertical axis. It's like, why? Why would it only happen this way? You know what I mean?
And if what Trvis, the ether band, this would lead to equal magnification in all directions, I feel, because it's more like a lensing effect. It would be equal.
Sure.
And
I mean, I get what you're saying. So I think that if you were looking at the house and if you just did an eyeball and felt like it was the same angular size, then it's going to be equally affected by the medium.
Mm-hmm.
I think that the thing that we need to take into consideration is the landscape that surrounds it as well. So that let's see. So okay, here's where I'm gonna spitball. Okay, you ready for me to spitball?
Yeah, always welcome here, Travis. Spitballing
Okay.
is the name of the game.
All right. So we have this niche in the tree line right here that I've tried to orient. Niche, niche, niche. Okay. Now, because these two photographs are the same focal length, I would expect that the field of view would be equal. That makes sense?
Yeah, absolutely.
Okay.
Ish.
You're in the same position, looking at the same subject matter. So just because it's different days, why would that affect the amount you can see in the picture? The field of view being the distance across the horizon.
Okay. So if this niche is this niche, then let's pick a rise right here. Boom. This one right here. This little tree canopy.
Mm-hmm.
Where is that on the left? Let's go over here, here. There's one. And there's one. But look how much more tree line is extended over here to the left that's not here. And the same to the right. So let's go over here. Let's find this. Okay, here actually this is even better. So, how about this? Here's the niche. Nothing below. Trees, 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 trees. Nothing here but trees. Nothing to see here but trees. Here's the green, 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 green. Here's a ghost. Here's a ghost. There's a ghost. But if I come over here, whoa, 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 where do these houses come from? There is a house right here that's not right here. Okay, so this isn't a ghost. This isn't a ghost. That's not a ghost. So if this house is here and I come over and I see this house, that's probably right there. So there's the tree line right there. Here's a house right here. So we can kind of go over and see where these tree lines are. Let's give it the benefit of the doubt and say that this, I don't know, like where's that next niche? Right? Here's a niche. There's a niche. Okay, look right here. Right? There's the niche. There's the niche right there.
Mhm.
Yep. Bro, go to the
Okay.
right in the left one. Check out this one. Have you caught that one? You see the tree sticking up just a little bit more to the right there? Okay, now
Right here?
now find it on the right-hand picture. And do you see where it's at?
Let's see. Maybe right here.
Bam. Yep.
Okay.
So
That's
that's
Okay,
stretching.
so if we keep going and there's a niche right there and there's a niche right there. So like right here under the 5, right there under the 5, there's a tree canopy. Right here I would say that's the tree canopy.
Yeah.
So I mean like this might even here be like this one right here could possibly be this one right here. But my point is that even if you had the same like even if everything right
well,
here
that could be
is right.
explained, and I apologize for cutting you off there, but if
No,
you
no,
look
you're
to the
fine.
right, those trees could be coming towards you, right? Versus the ones on the left are further away, maybe going away from you, possibly.
Well, but that would only be due to the conditions of the medium because that
No, I mean physically
land
in
and the distance.
real life. The ones on the right, like you see how the ones on the right in the left picture are dark and shadowed versus the ones on the left. That could just be
Well,
the
that depends
position
on
of
the.
sun.
I think. Yeah. Yep.
So I see what you're saying, Hammer. So the distance of the tree line in the left-hand portion of the photograph is further away than the distance of the tree line
Yeah.
in the right-hand portion of the photograph.
Right. So then the magnification would be more on the ones to the left, therefore
To
like
the left.
cutting off more
Yeah.
of the tree line on the left. It's how I
Yeah,
would
because
theorize that.
they're going
Okay.
through more of that. Your vision is going through more of that medium, so there's more of the medium for the magnification or whatever effect to take place over.
Just speculating there, sorry.
Yeah, well,
No,
it was a
that's okay.
spitballing session, but that doesn't address the question as to if the tree line in the right hand picture, the lower tree line, right? Travis, if you could put your cursor on the middle picture for me. Right. The tree line that we've just established is further away. Can you just highlight that to the left there? Right, so if you drop down a fraction, there's another tree line just in front of it. That's it. There's a tree line there.
Okay.
That tree line would obviously be closer. So is there more of that tree line cut off in the picture you're in now than is showing in the right-hand picture, the left-hand picture?
Mm-hmm.
And I think obviously there is.
Yeah. Right. Yeah, I would agree with that. Sure. So magnification, I think, is obvious. So if you can see here that Andrew Thomas Young, I think, does his work a disservice because he does not. Let me see if I can find it real quick. Andrew Thomas Young does not produce any images in real life. He gives you a diagram. Okay. So he gives you a triangle. All right. Now,
Mm.
this is the target with no mirage. And he has the horizon behind the target. The target is in front of the horizon. Now, he moves a kilometer away, and there's a mirage. He goes a kilometer closer, no mirage. Kilometer away, mirage. He is moving away. But you'll notice, here's the horizon now. The horizon now is in front of the target. Now he moves another kilometer away, intensifying the mirage and increasing the distance to the horizon. Here's the next one. This is the strongest inferior mirage. So here is the horizon. Now the default, right? Because if we go all the way back to the beginning, here's where the horizon ends. In the heliocentric model, where the horizon ends is curvature. So here's now, instead of the horizon being behind the target, the horizon is now here. This is curvature. This is curvature. This is curvature. The target is now 4 kilometers away from him. And so then in each of these, the horizon has been changing. However, you'll notice here, this red line, this is where the horizon began. There it is again. There it is again. There it is. My suggestion, DP, you already conceded with me, is that the mirage is extending over distance. Distance.
This is a perfect example of what we were trying to say to each other earlier, that the horizon line doesn't change, and what you're seeing is the reflection of whatever it is over the water surface. So that is not, like you say, it's not a it's at whatever angle you are viewing the water surface at, and this angle can change.
So the two things. If you were on a boat on the horizon here, I would see you. I could see you. There you are. You would be smaller because this target is in front of you, but you're right there. But now I can't see you, but you're still up here at that distance. You're still right there. And again, you're still right there. And again, you're still right there. But I can't see you. You're not down here. Right? But every time he moves away from the target, he increases the distance to the target, which then also increases the curvature between him and the target in his world. But part of my argumentation in all of this is that if I kept it open, that a boat on the water is always on the water in front of you. And the nature of the mirage requires that the full target, here, let's look at this. That's not a very clear image. Let's see, hold on. Yeah, I'm just spitballing right now, trying to, okay, here we go. Okay, so now, this is the same target, red house. Distance across, 6 miles. Distance across, 6 miles inferior Mirage. No Mirage straight across. There's the boat dock. There's the oil platform. There's the Red Roof Pavilion. Here's a sailboat. We can't really see the hull. But there's no question in my mind that straight across the water from me, that boat's on the water, and there's the hull. If you were waving to me on the hull, the distortion in the air is such that I probably wouldn't be able to see you, because in this image here, you're going to have a lot of activity that's going to be like that tower that I showed you where the air is making it dance. This is a still image, but if I showed you a video of this, it would be highly active. So my point is that if I were standing here on this shoreline, you probably wouldn't be able to resolve my image that well. But I'm directly in front of you, horizontal. Now, here's a sailboat on that same distance. It's to the left of the house, so it's over here. But regardless, I can't see the hull. Zanuck will tell you that the position of the sailboat is behind the curve. The hull is down here.
Who is this Zanuck guy you keep mentioning?
He's just a bit, you know, if you were on Nathan Oakley's, or more recently he's spending time at Earth Awakenings with Geo's server. But he's just a basic globe proponent. He knows everything about everything. Do you know who the Rumpus is?
In passing.
Hammer? Okay. He's the American version of the Rumpus. He knows everything, and he will out-talk you on everything. My point here...
Mm-hmm. I'm glad...
My point is...
Okay.
I'm sorry.
No, you're right. I'm very familiar with Zanuck. I just wanted to make a point out there that really, even though a lot of people in this community think he's some kind of big person, nobody outside of this community really knows who Zanuck is, so we should just put him on blast.
Yeah. Anyway, so, like, you know, how this is so abstract for me to wrap my head around. Like, you know, I don't know how it works for you guys thinking through this either. But this sailboat right here is in an inferior Mirage. Here's the top of it coming down, and then it reverts back. Okay, that's the nature of this Mirage. You've got a greater than sign here. You've got a lesser than sign here. Okay? And then right there in the middle is where the Mirage starts. Right there in the internal reflection, you have lost the hull, but it's right there. That means that this is all distance, distance, distance. Just like if you had a sailboat right here, you would see that sailboat all the way down to the water, hull and everything. And then from this boat to this boat is just distance. Now, what I was trying to say before, and we got distracted from it, is look at the texture of the water here.
Can I just say distracted in a nice way there? I hope, Travis.
Oh no, yeah, no, not at all. Everything that we've been talking about is worth repeating, rinse, repeat, rinse, repeat, rinse, repeat. Yeah, it wasn't a slight at all.
Nah, cool.
I just wanted to remember to come back to it.
Cool.
Okay. All right.
Yep. On you go.
So
this is fantastic stuff. I'm really enjoying this. Nice. Thanks for coming in, Travis.
Yeah,
well,
thanks
for having me. No,
Yep.
I appreciate it. And
welcome anytime. Friend of the server, Travis. Check out his YouTube channel.
Yeah, post the
okay.
Do a what do they call it?
A link?
Or just shout it out. And you could do a link too. I'll throw a link on the YouTube channel as well below.
Plug your channel.
Plug. There we go. Thank you. I'm having that brain fog.
Yeah. All right, so I'm just doing I'm so slow. Somebody could be beating me to the punch. I'm copying my web address. I'm going to put it in the chat.
Let's be official YouTube sluts, you know what I mean?
Whatever.
Yeah, absolutely. Do you want to give us a brief rundown of what your channel's about while you're doing that, Travis? Just
My channel is about everything that we're talking about right now. Basically, I've taken time out of my schedule, out of my life, to spend photographing, filming these phenomena. And I've done it on the East Coast, on the Chesapeake Bay, and I've done it on the West Coast in Ventura, California, on the Channel Islands. Oh, look, the beer man's here. Or he was. I don't know if he still is, but yeah, I didn't see that the chat was going that way. So I just put my link in the chat. So yeah, basically that's what my channel content is. It's just basically my research and my photography and video captures with a lot of my I've done live streams where I look up sources, read through the sources, try to debunk the sources, try to understand the sources, state what I think are uh, the the shortcomings of the sources. Primarily Andrew Thomas Young, but also Georgia State University has a video blog on physics. They call it hyperphysics. So everything under the sun, but they also have a section on refraction and mirages. And I've been in contact with the webmaster of that website. He's been a guest on my channel 3 times, I think I've had him on. The second time I had him on, he offered me the privilege of writing an essay or an article that he would put on his website, which he did.
Mm-hmm.
So everything that we discussed, he was impressed by and intrigued by.
And this
So,
is a standpoint that is counter to the standpoint that they have on the university website. Yeah.
yes, the things that I suggested in our conversations were things that I would like to put forth as challenging the mainstream narrative.
That's interesting.
So much so that he actually corrected a diagram based on my suggestion when I pointed out a shortcoming on the diagram, which was created by a PhD in the field who wrote a book on this very topic. And it was a gross oversight, absolutely gross oversight. And there's other things on the website as well that are still in need of remedy, but I'm not in charge of it. I can't do it. Anyway, so he gives me credit for that, but he also then said to me, you know, if you wanted to write an article, I would put it up. So based on what he and I had talked about, I just put it in article form with some pictures and demonstrations, not diagrams. I didn't have any diagrams. I had real life photographs to present in support of what I was suggesting. He put it up on his website so that anybody visiting the website could click that link and find out what I thought about Mirage. John Hawkins, a known globe troll, blasted their website in every way he possibly could against me. Not against the science, just against me, labeling me a flat earther, and the higher ups told my correspondent, you got to take that down. So they took down my content, not based on anything scientific, but based on complete libel and slander from Sean Hawkins.
And this is the point we were trying to make. This is all they have left. They cannot address the argument.
So, going back to this idea here, if you go to Andrew Thomas Young's website, as I said, he himself cannot provide for you any actual photograph of a claim that he's going to make. So when you go and look up refraction phenomena of mirage or non-mirage, so in the scientific community, there are 2 mirage phenomena, superior and inferior. And there are 4 refraction phenomena that do not have mirage. That would be towering, stooping, looming, sinking. Okay, those 4 are paired off. Towering and stooping are opposites. Towering, the image is stretched up. Stooping is compression. Looming is a lifting up of the distance, and sinking is a lowering of the distance, a target in the distance. So on one day, I might see the target. The next day, I might see less of the target. That's sinking. One day, I might see less of the target. The next day, I see more of the target. That's looming. Okay?
Can these effects be seen in combination with each other, Travis?
I have tried to, for anybody watching my channel, I have said there are numerous effects happening at one time.
Yeah. I mean, obviously, like towering and stooping can't happen together because they are opposites of the same effect, to
Right.
put it bluntly.
Exactly. Right.
So they can't be happening to the same part of the image, but it might be happening in a different part of the image where one part of the image might be towering and the other part of the image might be stooping. So the effects can happen in different parts of the image, but not to the same subject within the image.
I've not gone into investigating that, but I wouldn't say that it's impossible, right? We'd have to look and see if we can determine, but let's go back here. So my point is that if you go to Andrew Thomas Young's website and you can read the clinical definition and characteristics of looming, but you can't see what it looks like. Like an inferior mirage, like this target right here, right? You can see that it's different than, here's the target, here's the mirage, here's the mirage, here's the mirage. You can see that difference. It's a little bit easier to see that. If I were to investigate looming, all I would know is the clinical definition. I could define it for you, but I wouldn't know what it looked like. Does that make sense?
Absolutely does. Yeah,
Okay.
absolutely does. And I was just going to follow on probably into the next point you're going to make. So it does make sense. Carry on, Travis.
Okay. So I've labeled here two instances of looming, in my opinion. And that is, in contrast with the middle image here, can you see any difference in the appearance of the water between either the left or the right image in contrast to the middle image?
Other than the horizon line being, horizon line.
Well, that would be one, sure, yeah, but
the water line, yeah.
Besides the water line, is there anything else that you would say is different about the appearance of the water?
I would say it's more magnified. You can see crests of waves that appear to be bigger. Now, is that due to the ebb and flow and the swell of the lake? Who knows? But I would say that's a difference. The water itself appears to be magnified.
Okay, anybody else? Okay, so if we think about the heliocentric model where the limit of the water in the distance is due to curvature, I'm just going to, for the sake of argument, say that this limit to the water here is where the curve starts. On the other side of this, it's curving down and away, just for the sake of argument.
That's what the heliocentric model would have you believe.
Okay. So, how do I explain seeing more water here than here?
Sorry, I'm here, boys. I don't mean to cut you off here, but I'm here. I'm listening on YouTube, and I just grabbing a quick bite to eat, so I apologize. But I'm here listening.
And who was that for me? I don't know who that was. Who
that
just
was
came in
Hammer.
and said, oh, okay.
Your host with the most was just grabbing a bite to eat.
Okay. Okay, so do you understand my question? Right? My question is, if this is Earth curve, how is it that I'm seeing more water here? Their answer is that in looming, the refraction is lifting the curve up and actually flattening the appearance so that this is what Andrew Thomas Young says. I can probably just pull it up and read it. When looming happens, the convexity of the Earth gets flattened out so that, he says it this way, it appears as if the Earth is flat. So in this instance here, we have flat water all the way across to the other side. Now, the difference between this image here on the left and this image here on the right is I can clearly see these are houses. But if I showed you this image, I don't think you would think anything there was a house. Right? And so you've got a house right here, you've got land underneath it, and then the water. I don't have any problem saying this is the shoreline. Right here. That's the shoreline. Now, I've gone to Google Earth, and these houses, some of them have boat docks. Like I would say, this is a boat dock, this is a boat dock, this is a boat dock. Like we're seeing straight across to the other side 9 miles away. But here, the resolution is gone. It's just not there. But my point is that we're looking over flat water all the way across. So you'll notice as well the difference between the resolution of the distance. This is distorted and blurry. This is not so much distorted and blurry, but I would still say that there's distortion there. And we have the extension of the water. So the similarities here are we have an extension of water all the way across. We have an extension of water all the way across. So looming for the heliocentric model is a lifting up of the surface. So here is curvature. In here, this is refraction. This is looming. It's basically flattened out the curve. Does that make sense?
I've just kind of noticed something interesting, that the picture on the two pictures on the extreme left are at the same focal length, and yet if you were to draw a line through your miraging line in the picture where your cursor is now, the shoreline would marry up with the picture on the right.
Oh yeah, sure, okay. But not over here.
But not over there.
Over here, you're right. Right. So yeah, go ahead.
The focal length, the two pictures on the left is the same, but the focal length picture in the middle and on the right is different, but the shoreline where you're miraging effect is virtually the same.
Mm-hmm. Well, let's say if I knew what day this was, I could go back and see if I took, because I take numerous shots. Like if I went out on this day, my practice is to frame the shot so that I have the marker and this landscape in the same frame. And then I also zoom all the way into the full optical zoom. So if I knew what day this was and I could find the image that was at 357, it would be zoomed in so that this part would be gone,
Mm-hmm.
and then this part would be adjusted. I don't know that it would match up the same way, because here's 357 here, here's 357 here, but the shoreline here is way too high. Like it's right here.
Is there, no, the buoy is bouncing around in the water, so that it wouldn't be possible to do it. I'm just looking at the way the buoy is different in the tree line.
Right.
And
yeah.
if there would be a way of working out the angular difference, I suppose it would be, between its position in one photograph in the tree line and its position in the tree line in a different photograph.
Uh-oh. Now you got me thinking about tides too.
Uh-huh.
the time of day, the tides change every day.
Mm-hmm.
High tide and low
I don't
tide.
think that it's going to be that significant. I mean, you've got this rust marker right here, and you've got the rust marker right here. You can clearly see it. Now here, because of the waves, it's not as visible. But like if this wave were to pass and the trough would expose the bottom of the marker, I think you would see this. So the difficulty is like how much play does the tether have? You know what I mean? So like if the tide goes out, then this would lower. I don't know how significant that is, but it's a point. It's a point to consider.
Mm-hmm. But then again,
Um,
you know, as you've clearly pointed out, Travis, these are observations you've made in your spare time to try and work out what is happening. You know, and you can't go to the nth degree measuring everything all the time. And the observations as they stand, I think, are absolutely spot on.
May even drive you mad trying to get that particular, right? Like,
Yeah,
to the point
absolutely.
you just
Yeah, I
gotta
mean,
know.
there's been times where I'm just like, I got to walk away from this because my mind is just going
Mm-hmm.
crazy. Um,
So much
one
so
of the
that it could
things,
drive somebody. You would just hypothetically here, if you wanted an answer, right? If everybody wanted an answer to this specific question, and you just couldn't figure out all the things, you almost could just make up something and just hand it to them and say, "Hey, this is what this is. Don't worry about it."
This is what you're looking for.
well, but see, the unfortunate thing about that is that, I mean, I agree to a certain extent, but on the one hand, that could also possibly get put into the category of indoctrination, right? I'm telling you what you're seeing. So I don't think that that's it's almost impossible not to do that to a certain extent, but because you have to give somebody some context. So how about this? Let's discuss this image right here. Okay,
What
now,
the fuck is going on there, Travis?
okay, so now I would be lambasted by the ballers, the Globe Flake Science Warriors, because it's a blurry image. Well, it's not. Nothing I could do with my camera would unblur this image. This is what Mother Nature is presenting. This is what Lady Aetherband is giving me, and I'll take it. So, does anybody have any idea as to what this could be?
I'd say it's a platform of some kind, gas or oil.
Okay.
I'd say is an extreme example of an inferior mirage.
Okay.
I'd say it looks and appears as though we are looking at the entire platform down to the horizon line. But in addition to that, it would also appear as though there is an additional horizon just below the service platform of the rig with a cloud layer
I'm gonna
off to the
also
right,
clarify
which
my
is
answer
reflected.
in saying that at this point I'm gonna say it's a combination of looming and inferior mirage and an extreme.
Okay. Let's start over here. You see my cursor?
Yep.
We've got I think we would all say that we're comfortable with saying that this is the oil platform. This is the top of the oil platform. We got a boom.
Yeah.
We've got the control deck. We've got this crane.
I'd describe that as the service decks. Yeah.
Okay.
Yeah.
All right. So you tell me where you think the water, like if this is the top, we're going to go to the top. Here's the top. You tell me where you think the base of the oil platform stops. Okay. So again, this part of the oil platform is not touching the water. I'm asking you to tell me where to stop the cursor where you think the platform is going to touch the water. Okay, so here's the top.
Right.
Stop. You're gone too far. In the middle of that black spot there. In the middle.
Yeah.
Up.
In the middle right here?
Yeah.
Yeah.
Okay, so we're gonna come over here.
That is where I think the water line is.
Okay.
Yes.
Okay. All right. So then what's this? Right? What is this? Because it looks like, the bottom of the platform.
That's our inferior Mirage, is it not?
But
Well, yeah, I think you're farther along in the discussion. When I first saw this, I thought that it was towering because this looked like it was being raised up. Like, because when I saw this initially, I thought that this was
This
the
is just from
horizon.
our conversation right now, to be honest with you.
Sure.
This is all you teaching.
Okay.
Because I come from,
Well,
you know, I mean, I've heard some of these conversations, they make my head spin, you know what I mean? I have a friend that was in photography. He would probably be right along with this conversation, you know what I mean? But for the most part, when it comes to optics and stuff, it's one of those things where it's like, it makes, when you're describing it, it makes sense because obviously I have two eyes and I live near the ocean and like I've seen stuff, you know, like this all the time without even thinking twice about it. You know what I mean? It's when you like really have to stop and like think about like what is really going on here and like what are we looking at, that
great.
it really kind of.
So, this,
Travis, I've
Yep.
just sorry to interject. I've just done a screenshot of that. Do you mind if I make a meme out of that picture?
oh yeah, sure. Yeah, go ahead.
Cool. Thank you.
All right. Here is the beginning of the, let me see if I can change the levels a little bit just to see if maybe some.
I think he's upset because we got the answer right based on his wonderful teaching, DP, is what that sounded like to me.
No, I'm not upset. It just makes it a little easier to. I don't think this is going to work. I'm not going to be able to clear that up. Okay, so this is where the video starts. We have this wispy black lost ghost monster smoke, right? Like, what is this? Okay, but over here, there's nothing. So if I were to continue to pan over in this direction, there would be nothing here in front of me, and all I would see is this horizon.
Yep.
Okay, so keep that in mind.
Yep.
If this wispy ghost were gone, I would only see Santa Cruz Island. Santa Cruz. This is Santa Cruz Island. Here's the topography. Santa Cruz Island. There's Santa Cruz Island. There's Santa Cruz. This is all Santa Cruz Island. There's the water, the horizon. Boom.
I thought that was clouds.
Okay, well, let's go farther. Keep that in your back pocket in terms of like trying to figure out what you're going to see. Okay, so right now I'm going to pan. Now it broke up, right? Here it is over here, but here it's broken up. Now it's not even there.
Oh wow! Look at those clouds there.
No, these aren't clouds. These aren't clouds. This is Santa Cruz
That's
Island.
island.
Look at that there, right in the center of the frame. Look, all the way across there. Can you see it?
I think I'm seeing what you're seeing.
There's the reflection. There is that reflective band.
Ah, good boy. Good boy.
Aye, sure. Good monkey. Very good.
All right,
monkey.
now here it comes. Now here it comes again.
Yeah,
Here it comes again. Now it's gone in the middle. Okay.
Wow.
Now I'm going to keep going because it's going over.
It's not smoke. Or is it?
Now look right here.
It's the top of the water.
Here's a seabird right here.
Uh-huh.
Okay. Now look how high the seabird apparently is above its altitude. Like its altitude above the water right here makes it appear like it's pretty high up. Okay. I'm going back. Now in here you've got this wispiness that's light. A moment ago there was a bit more of it. Let me back up.
Did you see that seabird just flit in and out of that?
Yep.
That band as well.
Yep.
It just dropped in and dropped out again.
Okay, now look right here. Right here, you've got this break in the dark. Okay. Now when I pan back over, it's gonna have already changed. Oops. It's gonna have already changed. So there it is. It's thick. I'm gonna slow down. I'm going to go back to the right. And there it thinned out. I can hear myself because I have my volume. I can hear myself talking. Like I'm filming this, talking about what I'm seeing because this is the first time I'm ever seeing this. So I'm talking to myself, going like, "What am I looking at?" So now I'm going to pan over, and you got a thin layer there. Nothing there in the middle there, and then there it comes. And now look right here in the middle. I think I'm gonna camp out. That part right there is gonna start growing towards each other. Those two dark, the top dark blue and the bottom dark blue are gonna merge. Some dolphins right there.
Well,
Let me
You
back
can
up because I just saw something. Hold on, let me.
you can see the top band thickening up.
Yes. Now, okay, this is minute 125. Okay. Now, right here is a pelican splash. Okay. So I'm gonna back up 10 seconds. This is 115. I want you to just watch over to the. Let's see. Okay, like right in this area right here. Just kind of look. Don't look directly at it, but let the splash catch your eye. Did you see it?
Yeah, yeah.
Okay. So, in my opinion, we just had a pelican dive down into the water, splash. Just keep that in the back of your mind as we keep looking through this. Now, what's interesting about this is that the apparent horizon right here has a tighter line to it, almost a crisper line than this one up here. This one up here is really dynamic. You can see the aether moving across the land or the waterscape.
Which would lead you to believe that that is cloud rather than water, I think. If it's not
right here, it starts to grow together.
That's a really impressive video.
You ain't seen nothing yet. It's not even over. We're only 2 minutes in. Now, the unfortunate thing about this is I only had one camera. Like, I'm having to try to catch as much as I can as this is changing before my eyes. Because now, if I were to go back to the beginning, this band is now thicker than it was before. Earlier, it was much thinner. So it's gotten more depth to it. Okay, so now you see that it's merged. How did I get out? Okay. Now, if I were to just show you this picture, where would you put the horizon?
Probably where the dark water ends.
Right here?
Yeah, yep, that's exactly where I got my mouse. A little bit higher, maybe a little bit higher to account for a little bit of the.
No, hold on. Let me back up.
I disagree with Hammer there.
I know. I mean, I'm just talking about without having this conversation. I'm just talking about before ever talking about any of this, and just if he presented this picture, where would you put the horizon? I would say that's where it is. You know what I mean? Without the previous knowledge that we've been given.
I'd move it up the picture under the same
circumstances.
I'd move it up the picture.
Really? You would have known?
Yeah.
I think you're lying.
Well, no, hold on. Let me put it to you this way. Let's say I went to Joe Blow on the street, had this screenshot, and said, look, I took a picture of the ocean. Here's a seabird and here's a seabird. And I said to him, what do you think this is right here? What do you think his knee-jerk response would be if he knew this was the
clouds.
ocean?
That's a storm front or something off the
Oh,
the
really?
horizon.
Okay.
No,
That's
No?
interesting.
You don't
I
think so?
think they'd say it's the horizon. Just a quick glance at that picture, explaining photograph of the ocean.
I think he'd say it's land.
Or land.
Yeah, or land, yeah, in the distance.
All right. Remember that
Splash.
What were you
pelican
going
splash that we
there?
saw?
What were you going for there? Because I feel like I ruined your whole.
I'll get the punchline later.
All right.
Okay, remember that pelican splash that we saw before?
Yeah.
Yes,
Okay.
sir.
Now, if I went back and showed you that this part here just filled in all blue. Before, this part here was the sky color. You want me to go back and show you?
No, it was, yeah.
Okay. You see how this is filling in? Before it was filled in, right? Before it was filled in, this is the sky. Right? We go over. See, it's starting to fill in right here.
Mm-hmm.
So when I zoom in at 3 minutes, I'm zooming into this part right here, and it's completely filled in. So right here in the sky, where the sky used to be, okay, watch for
It's
7
just-
seconds. Watch for 7 seconds right here, just a bit off center. Right there.
Yeah.
There's another
Wait.
pelican splash. But
Is-
that's where the sky was.
Yeah. That's above your old horizon line.
All right.
So that all the time that was water.
Correct.
Which backs up what we've always been saying.
Okay, now watch. Now, see what happened just there?
Go back.
Watch what happens. Okay, so here's the new horizon. Here's the new horizon. Okay, let's see if I can go through frame by frame a little bit. See how the new horizon is disappearing and the old horizon is lower? See how the horizon is not here?
Mm-hmm.
So this is not the sky. In this angle, from here to here,
Yeah, it's a
from
reflection.
here to here, this is not the sky.
It's water.
There's water here that we can't see.
That is reflecting the sky. Yeah.
Well, no, in my opinion, DP, it's the air that's the reflective surface. It's not the water.
Yeah.
So now I come over here to this island. This is the north of Anacapa. We've got another platform right here. I don't stay here for too long. I just come in and check it out. I couldn't resolve anything, so I think I zipped over to the other part. Okay, so now we're going to come back over to the other platform. Now, again, if you were on the beach looking out in this direction, you would see water, 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 sky. So this position used to not be water. It used to be down here. This whole section right here used to be sky. Now we're back here. And now the entire base of that
No.
platform is gone.
Gone. This video is incredible, Travis.
Because you couldn't
Appreciate that.
Because you couldn't ever see the bottom of the platform from the first standpoint, right?
Well, and if you go back to the beginning of the video, Travis, for a second for me, if you look at that picture, right, if you look at the what you perceive would be the horizon line, the lowest optical, that's it, that's the one. If you look at that and go to where the platform is, the middle of the platform, so that's it about there. And if you look at the there appears to be like buildings or a boat in between the legs of the platform, but what that is the reflection of the underside of the service platforms.
I can see it a little bit better here, right? Because here's this line.
Yeah, exactly.
And then here's this line.
Yeah, in the water.
But even this right here, DP, is not physical.
Right.
It doesn't exist. If you got in a boat and went into this event and parked your boat right here, you would not be hitting the platform. You would be, say, 1,000 meters from the platform still. Everything you're seeing right here is crammed right here.
Mm-hmm.
So now look over here. This is Santa Cruz Island. This is the shoreline. The top of Santa Cruz Island right here is right here. And then it actually comes into a reverted image. This is almost a triple mirage.
Yeah.
Here's
and
the...
If you go back to where your cursor was there, if you like drop down a bit, down a touch, there, right there. If you follow a line through there, you can see another like refraction line, like a mirroring line.
Okay.
Runs there's like a kink in the platform legs.
Yep. I'm good with that. Yep.
It looks like another mirroring event.
Right. So this is where I could show you also different targets. Remember how? Let's see if I can maybe pull it up.
And notice how it kind of seems like it becomes clearer at the bottom, right, of all of the refraction. Like
because
the clearest part of the oil platform you can see is like something you can't even really see. It's in that
in the top part of the image.
Right.
Because that clearer part is actually the top part of the image, closer to the service platforms. So in the reflection, the part of the image is clearer, that is the most blurred in the image you are looking at. Do you see what I mean?
Mm-hmm.
That's a really, really good point, Hammer.
So, what was I going to say? I had a thought to show you something in regards to this, and I don't know that I can go back in my mind.
You were sorry, Travis. I took you off there. There was
no, it's okay.
You were going off to the right-hand side in the refraction line. You were pointing out the coastline of Santa Cruz.
So, okay, so here is the normal vertical orientation. This is vertical. This is that same spot, vertical again. This is it upside down. So this part right here is this part right here, upside down. But here it is turned back right side up. So you've got if that makes any sense.
Yeah.
The other thing that I was going to say again that goes into this claim that I have that is antithetical to the modern science is that even though this image looks vertical, it's not. Now, we all know they built this oil platform at a 90 degree. We all know that. So this is vertical. However, when you get here, you are now looking over the horizontal. So let's go back to what I was saying before about the distance, right? So you got this light water here, you got dark water here. So from this dark water to here, well, let's put that as at 300 meters. And then you've got 300 meters, 300 meters, 300 meters, 300 meters, 300 meters, 300 meters. Here's the oil platform. So just like this bird is at a distance from this bird, and this bird is at a distance from this bird, all we're looking at is over distance here. So this is all water. And, we saw it right there. There it is. It's all water.
Go back to the other shot a minute.
So I can show you, what's that?
Can you get that center frame for us, Travis? I'm just going to do another screenshot, that's all, because that is such an amazing picture there, Travis. That.
Now, what's awesome about this too is I can show you. This is the optical focal length, right? I'm zoomed out as far as I can go optically. So I can show you this same platform in other conditions at full optical zoom, and it's going to be completely different. You'll see details, you'll see crossways, you'll see, whatever they call the base pylons or whatever, right? So this whole thing is compressed. This is compressed right here. And we're looking over distance, so it's like, oh, this is behind, like, watch, if I go over to here, Sean G will say, oh yeah, like, we can't even see the bottom, it's behind the curve. That's behind the curve. I mean, honestly. So I'll just slide this forward. Now,
bendy water.
Watch this. Watch this, guys. I'm going to play this for a minute and see if you notice anything about what happens. Okay, so honestly, I'm going to let this go for a full minute. So this is going to be like a pregnant pause. Got like 40 seconds left.
It's like an unveiling. That is incredible, Travis.
Yeah, but you're seeing what I'm not wanting you to see just yet. Okay, I'm going to go back. Now watch what happens with the platform when I drag the timestamp. You see what's happening? Can you see what's happening? What's happening to the platform? Come on, guys.
Hammer?
I mean, it looks to me like the whole image is dropping, not just the platform, but is the whole image
Correct.
dropping? Okay.
Yeah. And my camera's stationary. My camera's not moving. That's not me. The camera, like, I played it in real time. My camera is still. Right? I'm going to go back. Okay, here my camera is moving. Okay, then I come back here. I'm going to tighten my tripod. Boom. Camera is not moving.
Mm-hmm. Like the Skunk Bay footage, though, isn't it?
So now it's going to come back and develop a bit.
Do you have a name for this observation, by the way? Is this one called the diving seabird?
What did I call this anything? I don't know that I have called this one anything
The
yet.
diving pelican. I couldn't even think of pelican, the name of a pelican. Or as
Okay,
they
but
call them
watch-
in New Zealand, a bloody gannon.
A bloody ganon. So, okay. Here I believe watch at the base. Not where the Mirage is happening below. Maybe it's too far in.
Oh, look, you can see the.
Okay, wait. Yeah. Okay,
Yeah,
so
yeah.
here we go, guys. Here we go. You ready to have your mind blown? Okay, watch. Okay, so, oops. Okay, I'm just gonna give you the punchline because it's. I didn't catch it for the longest time. There is a ship right here on the horizon. There's a ship right here. Okay.
I don't see any ship.
I know, but if you look right here, there's a white part right here, and then a dark thin band right there. Okay, now this part of the Mirage is a Mirage. This part is ocean. The Mirage is developing. This black band right here is the ship.
Whoa.
Okay, this red.
Yeah.
Okay, and it's up here. Now I'm gonna push pause and I'm just gonna let you watch. I can't remember how long this takes, so I might just jump it real quick and see what happens. Yep, okay, it's still there. It's still there. Okay, look. Now look at the top. You can see the ship actually come into definition with a dark band.
So that white speck that's developing there would be like the bridge of the ship.
Right.
Yeah.
Yeah. And right there, you see now that dark band at the top? Right there? That's the ship.
Uh-huh.
Right? But it's squashed to hell.
And the hull of the ship is developing in the Mirage.
Right.
Whereas the bridge and deck of the ship are developing as we see it in reality.
I'm going to jump forward real quick. And again, here we go. It's now moving behind the platform. So now watch to the left of the platform.
Yeah.
Here it comes.
And you can even see its wash or its wake in the
Yeah,
Mirage.
I think so. I think you're right.
Right. Look at that. Would you look at that?
Would you look at it?
That's clearly a
Would
hoverboat.
you just look at that?
Oh, we have contention here. Curious says it's a hoverboat.
Okay, now don't fall for the misdirection. Now look at the platform itself. I think that we can see the development of the base with the sky through the bottom.
Yeah.
Okay, so oops. Okay, that was the end of that. I shot for a full hour, so that was the first 24 minutes.
And what kind of distance are you looking at there to that platform, Travis?
About 9 miles.
Uh-huh.
Um,
I've got a photograph of looking through the legs of a pier at maybe low tide from 18 miles. You can see the sky in the background behind the legs of the pier, which I think is quite a good shot.
Now, I can never remember where I put this stuff, and I always do it. I always tell myself where it is, and I can never find it again. I'm trying to find my. I'm just going to do a search for it. You guys mind if I show you something else?
No. All good.
Okay, let me try to find.
Some incredible footage there, Travis. Absolutely amazing stuff.
Yeah, absolute baller proof. Baller
Yeah.
proof.
Well, it will be once Shield gets hold of it.
Once idiots get hold of it, yeah.
Yeah. How you been, Curious? We haven't chatted for a while.
Let me see what it.
I was about to have a really bad headache today.
Yeah, I woke up with a headache today as well, which was a bit peculiar. Travis, Hammer, are you having fun?
I'm having loads of fun, honestly. I appreciate Travis coming by. This is very interesting for sure.
Yeah, I don't know
I'd just
why.
like to say apologies for the other day. You were absolutely correct about the idiot.
Who was that to? And not to not to name names.
Oh,
but
thanks, Curious. I appreciate you.
Seriously, dude, you was on it. You were right. Absolutely.
I'm trying to remember what I called the file that I can't find right now.
But let me just say that again presents a wonderful highlight of how when you walk into a situation without whole context of what's going on, sometimes you can all of us do it. I'm not pointing at you by any means. It's beautiful that we can highlight that in that you can walk into something and think you know what's going on and absolutely be 100% incorrect. You know what I mean? And not to say go ahead.
Yeah, what it does show, it shows how everybody gets suckered in to behaving like the one who's behaving badly as well.
Oh yeah, 100%. Yep. And the people that
How nobody will actually admit to that, you know? Or admit when you're wrong, and I was wrong. You were absolutely right. He deserved it.
Well, and
So-
it's recorded on there. Like I told you immediately when you came in, like you were right. Like my behavior in that moment was absolutely incorrect. Like you just excellently described there. Being suckered in. You know what I mean? Because it takes a lot out of you emotionally sometimes listening to this freaking bollocks all day.
Yeah, he was clearly unbalanced.
There was something that came out of that I'd like to talk about a little bit later. I wanted to ask Cleary his opinion on it. I kind of mentioned it to DP, but like it plays into the whole idea of like, what are some of these people doing out here that love to just put themselves out here, but like why are they doing it? You know what I mean? Why are they trying to be such a a name or a voice in the community when they have like clearly nothing to bring, or they're just, as Nathan Oakley points out, they're just being wankers, bro.
Okay, what I'm going to do now is, since I found this file that has both the before and after, is I'm gonna get this to the point to where we were right here. I'll just say it right there. And then this is an hour later.
And that
Just-
side by side comparison, it's
just in terms of the contrast, right? So,
and your camera hasn't moved in between these two frames,
not from elevation. I've been moving it. I've been panning.
panning.
I've been panning back and forth. But this is going to be full optical zoom. This is going to be full optical zoom. But look how much more of the platform we can see. We can even see the sky through the platform here.
Mm-hmm.
But here you can't see it. So, and then just look how it just grows. It's all of that. All of this space right here is compressed right here.
And this kind of doubles back to what I was kind of airing to earlier, in the compression in that top zone, if you like, above perceived horizon line is what I'm going to call it, because now the horizon line is only a perception. So would you say the compression in that top half happens at a faster rate or a slower rate than the bottom in the
Oh, yeah, I
compression
don't
in the?
know. I don't know. So unfortunately, what if we had had that same ship here? Like what would that have looked like?
Mm.
But look how the base is growing. You got more of the sky there. So in this next one is I think is a fantastic capture as well. I call this the looming unicorn freighter. Now this is a different platform, and this is a different location. Let me zoom up a couple of it until I get stable. I don't have really the time to take you through this, but when I was watching this, I felt like this was like an LSD trip, because this part here arches like a cat arching its back.
Oh,
I'm just gonna zip through at about minute 7, I think, the part
oh,
that I want to show.
there you go. Just saw
Yeah,
it.
you saw it.
Well, we could leave it as a teaser if you're running out of time. We kind of, I've got 2 hours 20 minutes now of
Whoa.
us going back and forth on this a little bit.
Oh, you mean a teaser to come back the next time?
Yeah.
Yeah.
I want to show you guys.
Well,
And this goes.
you just mentioned
sorry.
you didn't have enough time to explain it all. I'd like,
Oh,
for you to
no.
be able to go
What
through
I
it all.
meant was no. I guess what I meant was is just to sit here and watch. I mean, I would watch it because I love this. Like, I would just watch it. I'm just saying I don't want to. This
let
part
it
I wouldn't
roll.
want you.
Travis,
Okay.
just let it roll. Just let
All
it
right.
roll.
All right.
And if you could send me the video file, I could make a GIF out of it. So we could make the whole file like 8 seconds long, and the whole effect would be visible in that 6 or
Yeah,
8
I'll do
seconds.
that. I'll do that.
That'd be cool.
So what we have right now at the base. Oh, did you just see that bird disappear?
No,
I saw
rewind
a
it.
bird. Oh, the black one just flew straight into the legs. Ugh.
Here we go. Watch this one. Don't. Did you see that?
Yeah, at the bottom there.
Yeah.
I don't know how to creep it back one by one. Okay, but watch. Like, see where my mouse is?
Yeah.
There's a seagull that's going to disappear right about here.
Yeah.
Okay. Here it comes. Here it comes. It's right here. Here it comes.
Yeah.
So we've got an inferior Mirage. We've got this light here, whatever this is. It's being mirrored here. This part. So again, right here is where the inferior Mirage for the platform starts. Right here. So again, this is not sky. And what I've discovered is a default in interpreting this is you only have an inferior Mirage where you have a physical target. So they take it for granted that they're looking at an oil platform and they can say, oh yeah, here's the inferior Mirage, but they're not looking to the right or to the left. They're not applying the fact that the refraction phenomenon that's creating the inferior Mirage for the platform is also doing that to the sky. And they're thinking that, therefore, this is curvature. When
Can I get clarification on that real quick? And I apologize. When you say it's doing it to the sky, wouldn't it be technically doing it to the water?
I don't know what you mean.
Because I mean the sky. I mean we're seeing a reflection of the sky where there should be water, no?
Yeah, that's what I would say. But you said it's. I think I misunderstood or didn't understand what you meant when you said it's doing it to the water. What do you mean?
Right, the mirage is acting upon the water, no?
And see, this is
Okay.
where Travis. I said it was a reflection across the water's surface, coming from the object to the viewer, and Travis is of the opinion that the effect it takes place in the ether. Is that correct, Travis?
Yeah, in the air. Yeah.
So this is
So it's not to the air. The air is affecting the image of what, like, I'm you're playing it right now and it's awesome because it's got like the fire going, and then you can
Right.
sometimes see the fire, the mirage of the
Right.
fire below it, right?
Right. I would say that's when the waves are troughing. You've got a
could that
crest when it disappears and a trough when it appears.
Right,
could
but
that
regardless of
possibly
that, if
be?
you're not seeing the mirage, you're not seeing that inverted image, right? Like if
So
it's
did you
a
see that wave come in? Watch this wave. I'm sorry. Watch this wave come in to the right, or this crest, or a swell. Call it a swell. Watch this swell come in. It's pretty pronounced. So right there. Look at that.
Oh yeah. Could that not be a platform in the background? That fire that appears to
I
be taking place between the legs of a platform in the foreground.
I'll only say no because I know that there's no platform farther behind this.
So what is that flame effect that is being mirroring?
I
At,
don't know. I mean, this is sunrise, okay, right?
yeah.
So you've got sunrise going right here. So I'm gonna say that because this is a dark area here. I'm gonna
hmm
say it could possibly just be lights that are at the legs somewhere. I don't know. Otherwise, I don't know.
Could it be the sun reflecting off the water as it goes further out
Mm,
behind the
I
platform?
wouldn't have. I don't know. I don't know that I would say that. Only because the appearance seems to be the same. Like, if anything, I would say the angle of the light behind on the other side of this platform is hitting the angle of the sun is hitting something through the legs, because it seems to me to have the same kind of lighting as the
Mm,
other parts that are being
yeah,
lit by
yeah,
the sun.
yeah.
So,
See,
parallax.
that's what gave me kind of the question: is it another platform in the background? Is the sun reflecting off another platform in the background the same way as it's reflecting off of the one we can obviously see? Now, to me, the shape that forms, if you go back a touch, can you go back a touch in the video? Can you pause the video a second? Now, and can you put your cursor on the perceived horizon line, being the top of the swell? That's it. Now, if you can draw a square there, right, going up a touch to the right, That's it. That area there kind of looks like a mirage mirrored effect going on through the center of it. So you got the flame below and the flame above.
Yep.
So that kind of gives credence that it's something in the distance being reflected, and we can see it underneath. So that miraging line is a reflection underneath what we perceive to be the structure in front.
And that's a bit too abstract for me. I don't. I mean, I think I understand what you're saying. I don't know that I could justify it if I was going to say what you're saying. I mean,
Mm.
I'm not going to. I guess what I'm saying is I'm not going to say that you're wrong, but I think it would be really hard to prove the point that
Yeah,
you're trying to make. I'm interpreting this as that everything we're seeing here is the oil platform itself. Like there's like
right.
I guess what I would say to you is, in my opinion, this is not any farther in the distance. This is on this side of the platform.
Right. Okay. Okay.
Now, I think I panned out here because there's a freighter coming towards us on the right, or coming across the field of view on the right. Let me see if I jump forward a little bit. Here it comes.
The thing looks freaking huge compared to the platform, though.
Half of it's missing as well, no? What's that out in front of it? What on earth is going on with that, Travis?
So I'm just gonna stop it. I'm gonna try to get it better. It's not right here. So we saw it over here. Okay, look. So let's look over here. Everybody, attention to the right.
Mhm.
We have sky, 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 water. We do not know or understand that there is an inferior mirage right here. So right where my cursor is, that is not the sky. So here we go. Sky, 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 sky. This top part of the freighter is right here, upside down. So this sky is right here. So remember what I said about an inferior mirage. The nature of an inferior mirage requires that the entire target is in the inferior mirage itself. So this entire freighter is right here where my cursor is. So this everything from, so here's where I would say the mirage for the freighter is. Okay, so then right where my cursor is here, this sky is not sky. It's mirage of the sky. Now, I have no idea what that protrusion is. I don't know why it's doing that. I have no clue.
That is definitely the vessel itself, though, isn't it? You can see the containers in that protrusion.
Yeah, I think it
That's
is,
me.
but I just don't understand because
Um,
we don't have it. Look here where it begins, right? It's a little bit there, wispy. You see that?
mhm.
Right there, there's a
I
little bit of it.
I thought it was like a smoke just going out in
Right.
front of the vessel.
So, I don't even know. I don't even know what to do with this. Except for right here, keep your eye right here because you can see the mirage break up. You can see it kind of flicker right there.
Mhm.
Right there. So, instead of putting it up here, let's just make the mirage here. So the entire vessel is here. Everything below this is a reflection of what's up here.
When you say the entire vessel is there, so does that kind of give you a scale of how big that vessel actually is at a distance from you?
No, I don't think you can blink test this. You couldn't get a stock image of this freighter and hold it up to this image and try to do a blink test. It wouldn't work.
What's a blink test?
A blink test. Whew. A blink test is where you have the. I'm trying to think. I've done these so many times. Where can I take us? Blink test, blink test, blink test.
I'm just going to step away for a minute, gents, while you figure this one out between you. Be back in a couple of minutes.
A blink test is where you have a physical photograph with no distortion. And then you compare it to the target that you have a photograph of. And you hold them side by side and you try to correspond everything in the image to everything else. I don't know if that made any sense. Okay, let me see if I can do a blink test in these. There's a blink test. I suppose if we wanted to do a station identification, I could put a video on to just kind of like play while I look for this. If not, if you guys don't care if there's dead air right now and nothing on, but I'm trying to remember. I'm just trying to think through how I can take you to a blink test demonstration.
Could you
Good, brother.
let that video that you were playing roll for us? That'd be cool. I'd like to watch through that.
Yeah. Okay.
Making good times roll. I was just gonna do a quick Google search on it. I was just gonna consult Google, see what she tells me about it.
All right. So I'm going to leave this, and I'm going to drag this over to my other window.
My computer seems to be running slow for some reason, though. Retro. Blink test. How is Blink 182 still like a top search whenever you search for Blink? That's what I want to know. Blink test, and it refers to the commonly accepted 3 to 5 seconds during which a visitor lands on your webs. That's not what we're looking for, Chief. Specific to photography, maybe?
Maybe it's just relevant to this discussion and no one else really uses that term.
Is it a blink comparator?
I don't know. We all call it, everybody in this conversation calls it a blink test.
What is the blink test? That's... Yeah, for some reason it's just bringing up how to somebody judging your website in 3 to 5 seconds. My computer is running really slow for some reason. Probably.
It's almost like that container ship is pushing a wave in front of it.
Mm-hmm.
And
which it is.
That disturbance is kind of unveiling the container ship through whatever it's making the wave in. If you look at that protrusion there, it's kind of taking on the characteristics of how the water would act on the hull.
Yeah, being projected up.
Yeah. It's like it's cutting its way through this.
The bow wave.
Yeah.
Are you suggesting it's some kind of like aerial wake that we're seeing there?
Well, there's
Yeah,
where
basically.
it is. There's more water in the atmosphere at that particular point, isn't there? Because of the bow wave itself, which is going to increase the reflection properties of that particular, or refraction properties of that
It also depends on which way that thing
localized
is.
part of the atmosphere.
Sorry, buddy. There's some guys surfing. Also, like which way the boat's coming from or going, I guess. Compared to like where you're standing, the direction it's coming into your view. I mean, those containers are going to be stacked above the bow, right? Typically, they stack them pretty high.
Yeah. They certainly do.
Okay, so I think about the best I can do, and is to. Okay.
Give us you said it's a comparison of a photograph with like basically no quote unquote atmos. Is that what it was? Something like that? An undistorted image of a physical object?
Give me 1 second.
No problem, buddy. This day and age of multitasking, Travis.
So
I understand how important it is to actually pay attention to one thing.
Yeah, all right.
And blokes don't multitask that well.
No. Absolutely.
I find it hard to talk and file search at the same time.
Like I know that I have done this before, and I thought, okay, create a file so that the next time you do this, you don't have this problem. And I never remember where shit is. So I'm going to just open this up. This is the Anacapa Island, the south point of Anacapa Island, where, oh man, I wish I could find a better image, but I'm doing this. Let me see if I can find a better image. No, that's not going to work because it's a higher elevation. Give me 1 more second. We're going to try to find a better picture. I'm sorry. I feel like I'm. Okay, here we go. All right, this is a little bit better, I suppose. Let me see if I can change the levels if this goes. Okay, can you see the lighthouse?
I see the lighthouse.
Okay. So just to walk through this really quick. We have the Anacapa Lighthouse, which stands at, I believe, 273-ish feet. So its base is at 220. So then the lighthouse itself is roughly about 50 some odd feet. Okay. So this base right here, then on the ground, is at an elevation of 220 feet above sea level. Okay, so just keep that in mind. Over here to the left is the Anacapa Arch. The Anacapa Arch is a 40-foot high natural rock structure arch that we can't see. So we have the top of the island coming down into a typical greater than sign inferior mirage. So we have the sky, the sky, the sky, the top of the island. Inferior mirage begins, inversion of the island. This apparent sky here is a mirage. If we go all along the surface of the water here, here's the sky here, which is the sky here. Here's the sky here, which is the sky here. The reason why we have this dip is because the elevation of the island is changing, but the entire island is right here in front of your eyes. Everything is right here. There is nothing from this island missing. Now what I'm going to do is bring in a PNG of the island that I took when Captain Joe Mama took me out on his boat and oops. Okay. So this image is an image I took of the island about a mile away. Okay.
The image
So
that
the
you've
blink
imported in here.
Yeah.
Okay.
Yeah. So this is my own photograph of the island about a mile away. So so this is directly down to the shoreline. I mean, I'm a mile away. There's no curvature. We're seeing straight to the shoreline here. Okay, you can see the topography. You can see the island or the lighthouse. So the blink test would be line up the lighthouse. You see the problem?
Somewhat. I think so. The trees are in the water. Or the bottom of the island is in the water, I guess.
Right. So here's the arch. Right. So if I was gonna try to
Can you
change.
can you drop the opacity out on the PNG, Travis?
Yeah,
So-
I'm going to do that right now. I just pressed Alt instead of function. Give me a second.
There we go.
All right. So if I were to say, I'm going to put, this is where I would put the island, where it's at. This is where the island is at. Because it's directly in front of me. Now, if I'm going to match up the lighthouse, there's the lighthouse. Then and then I'm going to slide this over. Then the arch here would be underwater. So then a blink test is like to scale. You can't scale this.
No.
So now,
there is so much distortion in that photograph, you cannot scale that in any way.
No matter what you do. Sometimes it gets stretched out this way because you've got only a certain amount of land right here, and then it stops. But in terms of,
you not just basically said lateral refraction then, surely?
yeah, this is what I've been saying for ever since I started these observations.
Yeah.
Yeah. Yeah. I feel so bad because I actually have better, because I've spent time looking for this stuff, and I've found what I think are better instances of this, and I just apologize because I can't find it. So here we go.
No apologies needed.
I appreciate that, but
well, Travis, right? I'm going to do a presentation over on geos, probably towards the end of this week, and then Clearys going to follow that up with a presentation on hydrostatics and how it relates to the surface of water. My presentation is going to be about geometry and showing that the surface of water adheres to the let's say properties of a geometric plane. principles even. This is practically demonstrated and measurable, and this is transferable into a grid at the location where near enough a 1 mile stretch of water is measurable. There are 4 mile square. It is it is a 1 mile square that turns into 1 square miles of planar water surface. So I'm going to do a presentation on that at Geos at the end of this week. Then Cleary's going to do a presentation on hydrostatics. And why don't you after Cleary, have a presentation on Geos? Go for all this. I'm sure there are people out there that would be itching to go through this with you.
I could probably just find a live video or a video, because I think I actually made one to be played where I did this before, but I hear what you're saying. I appreciate that. So just real quick, this image here, you can see it on the screen still?
Yeah, we're still with you.
Okay. So this is platform Gina, and this is all taken from the same location, same distance, same focal length. So we have a tight inferior mirage here. It's just barely seen here. There's no inferior mirage here. This is the condition for looming, in my opinion. Here we have an inferior mirage where we looked at the duckbill earlier. Okay. And then this is that image here blown up a little bit with something that I worked on here. So I took this again when I went out with Captain Joe. I took a picture of Gina so that I could use it for a control. No matter how I try to match this PNG up to Gina in any of these images, nothing would match. Everything would be distorted, whatever. So the position that I have Gina in here is where I think she is actually on the water. So all of her stilts go all the way down, boom, there's the water. And in this image of Gina here, we have an inferior mirage right here. So what I did is I took Gina, PNG'd, flipped it upside down so that you have this coming in and then going back on itself. You got the boom here, you've got the boom here. So we've got this inverted image here. And just to go back to what I said before, the mirage itself is not a vertical image. It is over distance. But I guess what was I even thinking about doing with this? I guess if I pulled in the PNG and showed you the Gina in each of these situations, I wouldn't be able to size her up.
Mm.
But
I think that's the point we were going to here, was the blink test and how the optical distortion, you would never be able to get the proportions right from a true size representation of that, like your PNG. You will never be able to size that to anything that you're seeing in any of the other pictures. It would be an impossible task.
Right. So here's another photograph of the same platform from the same distance. You can hardly see any of the body. But you can clearly see here's this vertical, here's that vertical, here's the crane, there's the crane. So this dark spot right here is the control deck right here, but then the body is not even, you can't even see it. But if I were to slide this over, it would drop this whole thing down below the water line.
Mm-hmm.
But I'm telling you, this entire image right here is all right here in front of you. It's right here. And these are different degrees of an inferior mirage from the same location. There's the part top poking out, barely visible here. We've got it again, barely visible here, but we've got a boat right on the horizon. We have a boat a little bit farther away in its own inferior mirage, but each of these boats are on a horizontal plane.
Yeah. Could you just go through those pictures full screen for us, Travis, just for the video recording?
Like this?
Yeah, there we go. Yep, that'd be much better. Yeah, just to bring them up on the video screen. That's all. Yeah, perfect. And look at look at that first one. Look, you can see the bands of refraction in the water there.
Okay, so here is the physical water breaking the band.
Mm-hmm. And
So-
it's funny that my minimal description there, and you jumped to exactly the place that I was talking about.
Yeah, well, it's
Yeah.
a beautiful thing to watch this actually come in. They'll roll up, disappear, roll up, disappear. And I originally, when I first started looking at all this stuff, I thought that was a mirage. I thought what I was seeing was the actual mirage because the sky was right here. So I thought that there was a mirage coming into view because the sky was right here. And I've since then changed my mind that when you can't see anything above the apparent horizon, it's because it's not high enough to break the band.
Mm-hmm. And
Right.
do you know what led me to this realization, this exact realization that you have realized here? It was shout out to him, Bev, and his sunset videos, where it looks like the sun is actually bouncing off the surface of the water and then moving away from you along the surface of the water. It is an amazing video to watch, and that because what you're effectively doing in your head is shifting the horizon line and putting it further out than it seems to be. And you know, it is anything that happens below that refraction line is exactly that.
The other thing that I want to bring out. Oops, what is this? Oh. The other thing that I want to bring out, if I didn't do it already.
That is quality. That that video.
So this is a representation of what I'm trying to say about the mirage. Okay. Now, when we see a tree with its shadow beneath it, it appears vertically beneath in a 2D sense. But it's actually this. If you were to go right here, you would be 300 feet away from the tree. Right? You're not underneath the tree. You're away from the tree.
Mm-hmm.
And the same thing with the mirage. This is not under the boat; it's away from. And so, if I hadn't said it before, I'll say
So
it
hang
again.
on, go back one frame. That's it. So what you are effectively saying is that point to your refraction line, so your true horizon line, if you like, in that picture with your cursor. So where is your actual horizon? Right there. So what you're saying with your last kind of comment or statement there is that from just below where your cursor is there, the legs of the platform actually splay towards the viewer.
Mm-hmm.
Those two lines aren't perpendicular. The two white lines that we have there, one to the right of where Trvis is, that's it. That's the other one. So those two there, they appear to be perpendicular,
Right.
but they're not.
Yeah.
What's actually happening is that there is a focal point at the convergence point of the legs and the physical water. And from that point towards the viewer, everything below that point is splaying out slightly, only slightly, but they're not actually parallel.
Yeah. Yeah. Trying to think if I.
Which is the way a plane works, by the way. You
Right.
get that exactly with a plane.
Right. Yeah. Well, I'm a bit worn out.
Yeah, Travis. I mean, we've been going what 3.5 hours, man. That
Yep.
is great stuff, man.
Really good stuff, man. Really.
Well, I appreciate that, and again, I wish that I had not had to stumble and guffaw over.
Well, I'll tell you what. If you wanna tighten it up and come back and do it all again, we can sit on this one. I mean,
no,
it's
you
good.
don't have to sit. You don't have to sit on this one. I mean, if you want to publish it or whatever, publish.
Oh, it's
Alright.
going out. It's already been
Yeah.
live. We got 3 new subscribers as of from yesterday. So I know, I
Welcome
think you're
all.
one of them. I don't know if God's 420 was one of them too, but somebody else apparently liked it because we're now up to 52 subscribers.
Excellent stuff. Pushing forwards. It's good to hear.
Hopefully they,
And
this is what we need, man. We need just straight up information, facts getting put out there. The debate is over. The argument is
Yep.
over. We know what's going on. You know what I mean?
And
It's
we
just
know what
time
we
to
know.
push this shit forward, bro.
Yeah. And and for you to come in and just go through it with us, Travis, just shoot the breeze, and it's a discussion. We're just chatting about the stuff you've put together, and from what I've seen, oh my word, there is some phenomenal stuff there, Travis, and it needs somebody to get behind it. It needs putting out there.
Mm-hmm. Yeah.
The only way we can find out what is happening in that zone of confusion is to explore that zone of confusion. And that's exactly where you have been for the last 2 years.
Well, yeah, and again, not even that, because I would want to get people out into the event itself, so that I'm there with the camera,
Mm-hmm.
and actually, I do have a video that I put out where I had some friends of mine. We went cross country, and we had a truck, so they went into the event, and I made a couple of videos on that. So
Mm-hmm.
I've been working on that as well, but we need more people to do. I mean, we just need more people.
Is it the observations in different atmospheric conditions in different parts of the world? Is this what you're thinking we need?
Well,
more?
that's part of it too, because you've got people like B-Ball, who is in Hawaii, and it appears that even though there are certain subtle differences, he gets the same effect every single time.
Mm-hmm.
So to me, that tells me that his climate is so uniform that he's not really going to ever get anything different.
Yeah.
And because of that, for him, he's got proof of curvature.
Because he's got a consistent finding and nothing changes for him.
You
Right.
don't think he's being selective with what he's showing, do you? By
Well,
chance?
listen, I don't have any evidence of that. So
No.
I know.
like,
If he had evidence the other way, he would not be showing it.
yeah.
Well, his motives for doing what he does and showing the things he does show and holding back, if anything, the stuff he does hold back is complete speculation. So let's not.
So this one here is just a real quick contrast. This is on the trip west. This is outside Bonneville Salt Flats in Utah, and this is me standing right here, and this is Adam standing right here. So we are both looking at each other with the P900. This is my view of him. This is his truck, and here's his truck here. And so at this point where the truck is next to him, there's a solid image with nothing underneath it. And here, where Derek is turning around near me, you can see that the road it goes through. It's not a solid. So even here at the same distance and same conditions, we have a completely different refraction phenomenon.
This is 2 points of view.
And the one on the left is that IR? Is that been?
I don't know. I think I just changed the levels. No, because my camera's not IR.
Right.
This is a flunky. I just happened to see this in my file right here and pulled it up. But this is. I must have just. I think I tried to do this just to see if I could get any contrast. But here you can see where the wheel well is.
Mm-hmm.
So if it was in a normal, if I showed you this in the normal shot, I think that this would just be a dark blob.
Right.
This is 2
But my
points of
point would-
view.
Yeah, this point is what I can see, and this point is what Adam can see.
At the
He's
same
right
time?
here. Yeah, we're a mile away from each other.
How's that
These are
possible?
both screenshots from video that we both took.
How's the truck pointing in the same direction in the photos? If you
No, no,
guys
no,
are
no,
looking
no,
back
no,
at
no,
each
no.
other?
Oh, no. So let me go back. I understand your question.
No, I've just noticed Arwyn's joined us. Afternoon,
No,
Arwyn. How you
this-
doing?
This
Hello.
Hey Arwyn. This is Derek down close to Adam turning around left. This is Derek down near me turning around left. So this isn't the same, like we didn't snapshot this at the same time.
I gotcha.
But at this point, the truck is close to him, and at this point, the truck is close to me.
Okay, so you're setting up the truck to be similar from the two vantage points, basically.
Right.
And that solid aspect to the truck in the image on the left there, could that be due to sun position and shadow position, or?
Well, yeah, but see, right. So look what's here. So in this image here, we have a much farther inferior Mirage. So here's the mountain. Here's where the truck is. The truck is inverted. Here's the road. The road is all right here. We actually have a rise in the road, in my opinion.
Mm-hmm.
Okay.
Yeah, because that Mirage is always in a plane. That has to be stressed.
That's another, right, exactly. So another punchline is that if you have a Mirage, you can't have a drop off of miles and miles and miles and miles and miles. You
Mhm.
have to have a surface over which the air exists. But my point is is that we don't have the same inferior Mirage depth here that we have here. And the position of the sun is behind Adam here, which is why this is dark, and the position of the sun is in front of me, which is why it's all lit up. So the position of the sun absolutely has something to do with this, which is not a factor in any of the science. They never account for the position of the sun when they're describing this. So even though this is the same corridor with the same variables, this has a tighter Mirage where you can't see underneath the carriage, and this one doesn't.
So
obviously
you're getting two different effects in the same corridor, essentially.
Right. So you can't have this unilateral, oh, these are the conditions and blah 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 blah. Well, then why don't we have the same inferior Mirage presentation here? Because we're all at the same distance. Like I said, Derek went down to where Adam was. Derek came down to where I was. So the distance is the same.
So essentially, if you're depending on this to reify some model, might be a bad idea in simple terms.
Yeah, it'd be a very poor decision.
Would you say that's non-logical reasoning if you deduced from what we've just looked at, if you could then deduce that what we are trying to describe as optical was down to the curvature of where you think you live, would you say?
If I understand what you're asking, I would say yes. Yeah. Did I answer it in accordance with your question? Because I was
absolutely. Would
Yeah.
you say it would be down to non-logical reasoning? So yes. Yes was the answer.
Arwyn, I'll get you that YouTube link real quick. Hold on.
Yeah, thanks for swinging by, Arwyn. It's good to see you in here. We are live currently on YouTube, Arwyn. So please do not swear.
I'll do my best.
How's your Sunday, Arwyn?
Kind of boring.
Oh,
And
what?
rainy.
Being in here is boring for you?
No. But I just arrived, so this is the first time I'm checking this out.
Yeah, and it's good to have you here. Tony's been in a couple of times. Had a discussion with Bacon, I think it was, about gravity, which was quite a heated discussion in places, but good nonetheless.
You mean Sleeping Warrior, Tony?
Yeah.
Oh yeah, he gets very passionate about that.
Which is good, and I think that's advantage that an advantage that we all have. We all have a certain passion for the various strengths we have within this debate arena.
Just because we're still here hanging out, let me show you this real quick. The same target, Anacapa Island. Okay, this is just a highly refractive day. This is the conditions for looming where we see farther, and the activity in the air is just electric.
Mm.
So these are all the same focal length, and within the same, let me see what it is. 1:15. This is an hour. This is an hour apart, and then the last one will be 3 days later, same time. Oops. Hold on.
That's
for
beautiful,
anyone-
that
Oh, sorry.
desktop picture. Sorry. Yeah.
For anyone watching that doesn't know, Arwyn, he holds a show the early bird, the Flat Earth early bird show. What's the time on that, Arwyn, that you normally go live?
That's 1 p.m. Amsterdam time in the weekdays and 2 p.m. Amsterdam time in the weekend.
There you go. Subscribe,
Cool.
check it out. Great show.
Yeah. If you
Thanks.
want to
Okay.
drop a link
Oops.
for that in the chat there, Arwyn, we'll make sure that goes out on the
Oh yeah, sure.
in the show notes for this video.
I'm still trying to figure out what you guys are actually talking about because I cannot see the imagery of it even on your YouTube stream. So
Oh, sorry, bro. I went back to the. Yep, I need to get back to the Discord. Thanks for catching that.
Well, just real quick. So here again is the Anacapa Island, and if you remember, before we didn't have that image. This is the Anacapa Arch, and here's the lighthouse. Before we had a very intense inferior mirage where it was actually cut off right about here. So if I did an overlay on the inferior mirage image, we would be missing all of this to the left. But anyway, so in this day, this is the arch. You can see the sky just right underneath it. So the eye of the arch is down here, and then let me see what the time difference is. This is
wait, is that the
1:15.
Isle of Man?
No, I'm in California on this one.
Oh, okay. Yeah, that's definitely not the same.
This is 1:15, and then this is an hour earlier. Okay, so this image is later, an hour earlier.
Whoa.
Now, the science would say this is a superior mirage because they think that this horizon is the curve of the Earth. And my position is all this is mirage, and the island is up here. This arch right here is physically right here. So if I go back to this image here, you've got the lighthouse. But in this image, the lighthouse is indistinguishable. You can't see it. Refraction has just distorted it to shit. So you have this pillar and the arch. You have the pillar, space between it, you have the arch. But I'm cramming everything up here. Everything up here. Now, remember what we saw with the platform. right?
That looks like an
Platform was-
eye. That's an eye mirage. Really freaky.
Well, right, but see here we've almost have like 4 different images here because in order to have the eye, you'd have to have closure. So
Yeah.
the top of the arch is here, the bottom of the arch is here, and then you have it again down
Again,
here.
yeah. So it's like that doubling of the mirroring effect, which is what we were seeing in the legs of the platform.
Right. Right. And the science would say that the actual arch is down here, presenting everything up above, and I'm saying that
Yeah.
concept of a superior mirage does not exist. So
Yep.
I've said
What?
in my channel, superior mirages do not exist.
I have a bit of a technical issue with your wording. Science says. I don't think so. Science is not sentient, but beside that, it's not an official claim. I mean, official optics does not claim that the horizon can actually displace in relation to the horizon due to refraction, which is the root cause of all mirages at the horizon. So I disagree. I mean, baller fanatics will tell you that, but it's not even officially claimed. It's just a bullshit story they have to make up on the spot to justify why it's flat. But it's not an official claim.
Yeah, Travis, Travis,
Mhm.
go back to that picture where you asked me and Hammer, where's the horizon in this picture? And ask it of Arwijn.
Was that the one with the video of the art of the platform?
Yeah, where the Mirage closes up with the actual water line, if you like.
I think I understand what you're asking me. Now I'm gonna have to go back and find it.
Should have
While
got a
you're doing that,
screenshot
I'm
of
gonna
that.
make sure I'm gonna get Arwin's video into or link into the video we're currently watching. So everybody look out for that.
What? Already there.
No, I'm gonna put your link. I'm gonna link your stuff in with the video. You know what I mean?
Yeah, thanks for swinging by again, Arwijn. Chilled discussion on a Sunday
If I can
afternoon.
figure out how to
Yeah,
push
sure.
it.
No problem.
I think I remember I did this because I took it off screen so I could set it up for you guys. Okay. All right, Arwijn, here we go. How would you describe what you're looking at, Arwijn?
Yeah, what? Where?
Yeah,
You saw something, then you dragged it off screen.
can you
You
look
have-
at Travis's live stream, Arwijn?
I'm sharing my screen, so you have to click my name. It says live, right?
Okay.
Can you see my screen now?
It's taking its sweet ass time. I'm sorry, but I'm watching it.
Coming in really low, bud.
Your mic just dropped a lot. Your volume is really low now, Arwijn.
Oh. Just saying, I'm watching it on YouTube because the Discord video.
Oh, he's watching from YouTube, so he's a little bit behind.
Yeah.
But
Yeah.
it should be up on there now, hopefully.
I'm holding it still, so I'm not moving anything just yet.
Right. So yeah, what I'm seeing here is a very complicated situation, but it's very clear to me immediately that the horizon is way in the back, and what you're seeing below that is basically a reflection.
When you say the horizon is way in the back,
Yeah.
are you talking about the highest dark band?
Well, where it's going to converge, basically. The actual physical place.
I'm not sure I understand what you're trying to.
Horizon is definitely not down there. That's just where the.
When you say it's definitely not down there, do you mean the very lowest part where you have a line across the screen? Can you see my mouse? Well, I guess you're gonna have to wait 10 or 15 seconds.
I'll tell you what, Arwijn, why don't you do a screenshot of that, and then we'll look at your screen, and then you can take it apart from the screenshot and tell us where you perceive the horizon and what you think is happening in the picture.
Well, the horizon is pretty much at the top of the rig. Yeah, whatever. It's like an oil. So you have like the pillars below, or so it's they're part of a reflection thing.
Yeah, I think I understand what you're saying. I think, yeah, I would agree.
The thing in the background is actually concealing that which is being reflected, which is.
Yeah, I think Arwijn's on par with what we were saying is happening.
Sounds like it. Yeah.
Yeah, but can you spot a mirroring effect in the lower part of the reflection then, Arwijn?
Yeah, it seems all mirrored.
Right, but it's all mirrored once, but then there is part of it that I believe is mirrored back on itself. And that is the portion closest to what would be termed the horizon, i.e. the edge of the visible water, shall we say.
I think
Right.
Oh, sorry, buddy.
Oh, well, my point is that the reflection is actually showing more than the non-reflection, which is really weird. So there might be a combination, both the reflection and sinking, which is also visual displacement downward. But yeah, bizarre sighting.
Emma, you got a bit of hot mic going on there.
Sorry, guys. Sorry about that.
No, all good, all good. Yeah, so Travis, it's been a long one. We're what there, almost 4 hours on that one.
Yeah, I know, right?
Yeah.
All right. Well, I am glad that we were able to touch on some things that I think are key, and despite the dead air time of looking for certain things, yeah.
It's an organic conversation, Travis, you know.
Right,
sure.
we're not looking for
given.
people that have like short-term memory or like attention issues that can't sit still for like more than 2 seconds. You know what I mean?
Yeah.
Even though
You have to
I get
stay
it.
with the
There's a lot of
conversation.
those out there.
Oh yeah. Oh yeah. Well, we're trying to up the level of consumership here within the community in order to propagate this information outwards to the masses. You know what I mean? You feel me?
Okay. Well, if you want to go out to the masses, you're going to have to be a lot shorter, a lot more enthusiastic, a lot flashier, and a lot more bland and dumbed down.
But do you think everybody goes for that though, Arwijn? I know that's like what they put out there for the consumers as like a cheap way to get attention, right? But don't you think that can be burnt out? You know what I mean? Don't you feel like people are getting burnt out from that? Just constantly being bombarded with stuff.
Burn them out. It's the point is to burn them out and to aggravate the loss of attention span. That is the entire point.
That's why we have memes.
But what I find is something completely amazing about the human condition is that we can get so run down and so like to the point that we don't feel like we can go on any further, and there is something within us that can drive us to overcome.
A second wind, that's what that's called.
Yeah, but you get that second wind, then you get that third wind, and that fourth wind, and that fifth wind, and how many
eventually,
winds?
No, it doesn't work anymore. Either it then blends in an average, or you just lose.
No, or you find your zone and you comfort in what you're doing, and you get the drive from what you're doing. So that becomes a self-perpetuating engine then.
I can't believe you missed that one. You could have said the R wind.
I literally described described that. It averages out. That's what I said.
Yeah,
But then you don't get that anymore. Once you get going, you get going. But if you get stuck, yeah, then you can have a second win situation. But you can't keep getting stuck and then getting new second wins because eventually it's going to break you. Trust me, I've been through it.
Right, I'm out of here. See you later.
All
Bye-bye.
right, and Curious,
Bye,
cheers for
Curious.
popping in.
Take care.
Excuse me. Oh, that was a good run through, Travis. I enjoyed that.
Well, I appreciate it. Yeah, I appreciate you giving me the space to and the time.
No, well, you know, if we can arrange it and we can do it in here, then we will do it. You know, one time it might be Cleary, not me, or you know,